Here we are, 2022, June. Okay, it's actually, this paper was actually written in May 2022. It's the math paper 1, grade 12 memo. And that is what we're going through, the whole thing. We're going through all the questions without leaving anything out. And obviously, depending on everything that I'm going to mention, right, the big idea is for deeper and more, structured ways of learning, you can hop onto our online platform, right? So the online courses on our online courses platform, which is our online website, you will find the entire syllabus there, all the topics that you need to learn from start to finish in different, courses, etc. So you can always just click the link in the description, and then you can always get there. And then obviously, if you need to hit me up on IG, you need to ask questions, etc., you can always DM me on LE_EVY. What happened to the underscore? Hectic. Anyways, let me start. Let me not waste anybody's time. Question number 1. What does question number 1 say? Question number 1. What is question number 1? 1.1 is asking us to solve for x as usual. Now, fortunately, here are factors of 15 that can give us a 2. I think we have 5 and 3. Yeah, so this we can factorize easily. 5 and 3 is going to give us a 2, but to get a positive 2, it has to be positive 5 minus a 3. You see, so this is like 100% fine. And then what do we have here? So this is going to tell us that x is equal to negative 5 or x is equal to positive 3. So this is not a difficult question, really. Nothing crazy, nothing major. Moving on, it says here, leave your answer correct to decimal places. So normally in a situation like this, they definitely want you to use, what is this? They want you to use the quadratic formula. Quadratic formula, what? That's weird. The quadratic formula. So in the quadratic formula, we know that our b value is like -1 there, and then our c value, what is our c value? Is a negative. Now, why am I talking about the c value when I'm still writing the b value? See, you're trying to get yourself confused here. But anyways, let's see here. C is like -9, and then the a value is positive 5. Okay, perfect. Okay, so we have to put all this in the calculator. So, and I'm like, it's a bit dark here because there's loads shedding. There's loads shedding, and I'm busy doing the paper, so I can't even see nicely. Like, this mhlakazi must come back, please. Otherwise, we're gonna have a problem, But I'm just putting this nicely here: -1 squared minus 4. So I think while I'm doing this, right, let me just take the time to say, if you spot any funny business, any small error, usually I normally spot it like maybe after like a few steps, and then I usually like come back and fix it. So yeah, just bear with me, ne? Just bear with me. So this is one of the answers, or x is equal to, let's check the other one here, is, what is it giving us? -1.25. -1.25. Okay, perfect. So with all this being done, ne, this is the big idea. I obviously want to check these answers because, like, so you can just use one of them in the calculator. So in the calculator, I'm putting the ans 5 and then ans squared, and then here minus the answer, and then -9. What does it give us? A 0. Perfect. So you get your answers and you keep it moving. So the one thing that I've noticed though in some memos is that they normally want you to like have like an extra step here before your final answer, which is kind of weird and dumb, but you can't argue with the people that are going to give you marks. You just have to comply. So what you can actually do is before your final step here, right, you can just just try and simplify first. So you see here, this negative and a negative is going to give you a +1. And then here, let's see, this is, you can just put all this in the calculator actually, because yeah, why not? Why do you have to risk it? Let's see here, -4 times 5 there, and then multiplied by -9. Okay, what does that give us? Gives us something very interesting. It's giving us a 118, so it's like 1/8. Hi, boy, this thing is not writing. Brody, sure, why is it writing weird like this? 181. So I really don't know how long this paper is going to take, but since you're watching it now, you obviously know how long it took, and yeah, it is what it is. So this question was actually x squared. Hey, right in black, bro. Come on, Brody, black. It was actually x squared equal to 3x. So it's a 4-mark question. They're asking us to solve this inequality. So solving this inequality, this is how I would do it. You know, I was actually going to psychoanalyze this by actually drawing the sketches here. So in a Cartesian plane, right, you have to remember that this is a parabola. It's a standard parabola. It's going to look something like this, you see. And then this is a normal straight line graph. This straight line graph, it has a y-intercept of 0 also. Because you see this equation here, you can almost look at it as like y is equal to like 3x. And then the equation here, you can almost look at it as y is equal to x squared. You see two graphs. I don't know why this thing is like doing this whole jamming thing. This thing needs to be replaced. It is ready to be replaced, people. Ready to be replaced. But anyways, let's see. With all this being done, the one way I would work out this question is, I'm actually thinking to myself, bro, why don't you just take everything to one side and then factorize? But here I am doing some funny stuff here. I am very, very yeah, let me not be extra. Let me just be sober. So let's take everything on one side. Let's move all this funny business here, because that's really all not necessary. If we take everything to one side, right, we're gonna have x squared minus 3x, where is it bigger or equal to 0? So this is actually a parabola, right? Where you firstly actually want to just solve for x in this parabola. So solving for x, you know that you can take out x as a common factor. You're going to have x here minus 3. And then you're going to see that your 2x intercept, you're going to get, well, you don't need a y-axis. You just need, but come on, bro, the x-axis only. This is clearly a smiling graph. So you're going to draw something smiling like that. Your one intercept, we can see here, it's going to be x is a 0 or x is equal to positive 3. So somewhere at positive 3, we have an intercept. Somewhere at 0, we have an intercept. So answering the question, you can use your sketch now. Your sketch is asking you, or your question is asking, where is this graph below or equal to 0? It's below or equal to 0 here. You see this part here. So your answer, you're going to say it's between 0 and positive 3. So x is the element of 0 until positive 3. Going to get 4 marks. I feel like these are very easy 4 marks. Like literally, like, yeah, see. Moving on. Okay, we have a very easy also question here. So it's saying here we're given this expression, right? And they're asking us to solve for a. So solving for a is not a hassle. It looks like what you can do for yourself is, what are you going to do, bruh? Okay, so actually because the a is down here, right, it's kind of making things a bit weird. So what I'm going to do is I'm going to take the a to the other side. The reason for doing that is because we want to multiply both sides by a like this. So if you multiply this by a, multiply this by a, this a cancels the a at the bottom there, then you have like 64, right? And then here you have a times 16 is like 16a, a times negative a is this square there. If you put everything into your calculator, no, what calculator, bruh? We're still working it out. So let's say a 16a, and then this goes over, that's like negative 64. So this we can put it into the quadratic formula. You see, minus b plus minus b squared minus 4ac. Actually, I don't even know why I'm putting this into the quadratic formula when we can factorize. Looks like we can factorize. But hey, somebody is feeling lazy. Why are you feeling lazy, my guy? I don't know. Did I really just ask myself the question and answered myself? That's weird. But anyways, b squared, that's like 16 squared. A is like a negative 1. C is like negative 64, right? And then what do you have here? A is like a negative 1. Okay. So I did say I'm low-key in the dock, but somebody has got his touch, so I can touch the calculator. Lol. Okay, that's not funny. So negative 16 plus square root of 16 squared minus 4, negative 1, and then we have the negative 64. Is that negative 64? Yeah, it's negative 64. And then the a value is like negative 1. Great. A is 8. And what is the other value? A is equal to 8. Or let us check the other one, because there are two values for A. Two values for A. So it's 8 and 8. Oh well, we're just gonna write both just for the vibes. Moving on, it says here, hence solve this equation. So any question that starts with hence literally is telling you use the previous question to help you answer this. So in this setup, normally, the way this is set up, you can write it as two separate bases with two separate exponents with the multiplication symbol, because technically the bases are the same, right? So we just added the exponents there. But the reason for doing this is, you see here, there's something with a negative exponent. Whenever you're dealing with stuff like that, you can always just put them under whatever is in front of them. You see, so here it's like 2 to the power of x, and then this you can take it under the 2 to the power of 6 there. But then the moment you take this down here, it has to now have a positive exponent. So the reason for doing this is, in your expression, right, it looks as though there's 2 to the power of x there, and then here it's 2 to the power of negative x. So it's usually better for you to have things that look alike. So for this to end up having a positive exponent like the 2 to the power of x here, we just have to take this and drop it down there like this. So the way this looks, it looks just like what we had up here. There's a 16, there's something here with a fraction, and it's something on its own. Fortunately, 2 to the power of 6 is 64, you see? So this is clearly telling me that wherever a was in our previous question, that's exactly where 2 to the power of x is, you see? So here, we can see that a, you can here, you see, let 2 to the power of x equal to a. We are going to have a plus 64 over a. You see, so what we know is that a is equal to 8, you see. So wherever we see a, we can just put 2 to the power of x there. And then this is 2 to the power of 3. And then therefore x is at 3, because for these two sides to balance out, the exponents have to be equal. So on this right side, we already have a 3. This side is x, so these have to be equal. Simple and straightforward. Nothing crazy, nothing major. This thing is too bright, actually. Okay, let's see. Hibo. The next question, 1.3. Without using the calculator, calculate the value of this. So the idea with questions like this is you always want to take out a common factor based on the lowest exponent that you have. So what that means is, you don't want to square anything here. That's not going to help anything. So what you want to do here is, the highest exponent here is 998. So what you want to do is, at the top, you want to write out this exponent as you can take out 998 as a common factor. 2 to the power of 998. Whatever is left, you see it's going to be 2 to the power of 4, because 4 plus this would give you 1002. And then here you're technically going to have 2 and 8, because 8 plus this would give you 1006, you see. Because if you were to multiply inside, you should always be able to go back where you started there. Down here, we can take out the 2 with 998 here. And then, what do we have here? We're going to have 17. What is 17 now? Yeah, we're going to have 17 here, right? So with 17 there, this can cancel this. Yes, like, and then what? What do we have? What the hell? Yeah, they say without using a calculator. Hey, if they say don't use a calculator, you just have to finesse the question. You literally just have to finesse the question. But then 2 to the power of 4 is, I think, 16, because this is not that's not difficult to see. So what you can actually do is, let's take it slow. Let's take out 2 to the power of 4 at the top. We'd have a 1 here plus 2 to the power of 4. And then the reason for doing this is so that we can work with smaller numbers, you see. So this is going to give us 16 here, 1 plus 16 as well. And then we have here 17, right? So this is going to be square root of 16 times 17. And then the 17s cancel each other out. And then we have square root of 16, which is equal to 4. Nice. So you get your answers and you keep running, my guy. You keep running. You don't just answer the questions and you stay at them. Well, I mean, you can double check, but I think everything is fine here. That nothing seems out of place. For 6 marks, they want us to solve this simultaneously. This doesn't look so bad. I think it's best if you isolate y, because yeah, x is already down there. So yeah, it doesn't look like it would be good for us to make x a subject to the formula. So this equation, we're going to throw it in there. We're going to have here 1 over x, right? And then here our y value is 2x minus 2. And then what do we have now? This is equal to 1. 1 over x with 3 times y, right? So what do we get now? Why am I stopping? Why am I stopping? I feel like I'm getting distracted because of these notifications coming in. Hi, man. Hi, man. Come on. Come on. Come on. Let me decrease the volume. Anyway, so what's the thing? What do I need? What's next? Oh, solving for x. Oh yeah, so solving for x, we have a fraction here. So this may be a small problem, just a small one. So the best way to deal with this problem is just take everything to one side and leave the fraction on its own. You see, so you're gonna have 1 here. Let's see here, 1 over x, and then plus 3, 2x. Hey, well, come on, bro, come on. 2x minus 2. So you took this whole thing here to the other side. So because this is already in brackets with the negative 3 next to it, you just have to change the negative 3 here to positive 3. Because now, why am I even doing all this? You may be asking. Well, the reason for doing all this is, I mean, eventually we're going to need to get some kind of, we're going to have to get rid of the exponent. So the easiest way to get rid of the exponent right now is if you multiply both sides by x. But before doing that, let's maybe make this side, less crazy. Hey, positive 6. Bruh. Come on now. So this is like 1 over x. Whew. Okay, so now we can just multiply both sides by x, right? So this is gonna be come on, bro, times x here. The whole thing here you have to multiply by x, or rather, let me firstly clean it up so that at least we don't have too many, too many numbers that are on their own. So here 1 over x, here 1 minus 6, that's like negative 5. So now we can multiply by x on both sides, you see, because why not? Because why not? Why not? Homework. Yeah, this thing's not coming out nicely. Multiplied by x. Here you have to multiply the whole thing by x. So what's going to happen here is that this x cancels that x, and then this is just 1 is equal to 6x squared, because you see you're multiplying this times that, this times that. And then you have to put everything in one side and then put it into the calculator. So putting everything into the calculator, yeah, we have to be careful. You see, we have to be careful. So everything into the calculator, let's see what we can come up with, because, it is what it is. Wait, no, it is not what it is, bro. I feel like sometimes we all say that when our vocabulary fails us, it's like, what do we say next? Nothing to say. Let's just say it is what it is. Yeah, I'm just being crazy right now. Okay, let's see. Negative b. I'm already putting stuff in the calculator, but I didn't write the quadratic formula. I wanted to write out the quadratic formula. So I wanted to write out x is equal to minus b plus minus b squared. B squared minus 4ac, the whole thing over 2a, right? And then what, bro? X is equal to minus b plus minus what? What is b now? B is -5 squared minus 4. What is the a value? A is a 6. C is a -1. Okay, come on, bro. Come on now. Yeah, the stylus is not doing the things these days. It needs to be replaced, like literally. So the a value there is like a 6. Perfecto. So all this being said, right, or all this being done, rather, let's see. So what do we need? What do we need now? Think, my bro. Oh, the calculator. We need the calculator. So in the calculator, let's see here, b squared is like -5 squared minus 4. A value is a 6 and a -1 there. There we go. So the first value is -8 over 3. -8 over 3, or what do we have there? -3 over 2. -3 over 2. So -3 over 2. -3 over 2 is the next answer. So these are our two values for x. Obviously, as long as we have those two values for x, we can then use them to get the y values. So getting the y values, we can just obviously use this equation up there. So in that equation, right, we're going to throw in our x values. Let's see here, -2 is equal to y. And then what? This is like, I don't even know why I'm not using the calculator here, but let's just do the other one, and then we can just use the calculator at once. My back. Sitting down is not the nicest thing in the world. It's like, I want to stand, but let's see. What I have to -2 equal to y. So the two answers, well, the calculator is going to have to help us with this one, because why not? Why not? Why do we have to use our brains when the calculator? Okay, let me not sound like a lazy person, but I don't know, man. I'm just trying to, like the best habit you can have when going through exams is to use your calculator as often as you can, you see. Because when you're trying to do all these, mental math things, you're going to cry, my friend. You're going to cry. Now, the other thing also is, like answers that are decimals, they're a bit discouraging, eh? But then because this is already a fraction, it's like, you know what, let's just take our answers and then test them when we're done. The last thing you ever want to do is to leave your simultaneous equation questions without testing them. Because if you don't test them, you're not going to have a good time. Okay, so you're not going to have a good time. So let's put these answers, and then we'll just see what we can do. So this is x is equal to -5. Perfect. You see. So yeah, let's test out the answers. So the best way to test out the answers, we might as well use this equation because this one already gave us something. So let's turn to this one. We're going to put an x value and its corresponding y there. Let's choose these ones, -5 and -3 over 2. So in the calculator, let's see here, 1 over, let me put brackets there. The fraction we are using is -3 over 2. And then the y value we're using is -5. So this is like -3, right? And then -5. So that's like not giving us a 1. Baga. So the question is, the answer is wrong. Pain. Let me see where the error could have been. I think since you're watching, you obviously maybe saw where the error happened, and now I'm just acting like, hey, let's find out where the error was. So these kinds of things, you see, it's not like cut out, mainly because I'm trying to also give you the idea that always just double check your answers at the end, because anything can happen at any time, So let's see what happened here. Where did the 3 come from? Oh, the 3 came from here. So anyways, we took y to the other side. We took the 2 to the other side. So this became a negative, this became a plus. And this value of y, we threw it into the second equation. So in the second equation, wherever y is, we put 2x. We put 2x minus 2. And then what happened was we took this whole thing here to the other side. So it became a plus there. And then the one is still here, right? And then we multiplied inside. But then what could have been the issue here? I mean, like, whichever way, right? I'm like, you may be thinking that this is probably the error, right? But then even if you multiply inside here, you're gonna have here 1 over x, right? Minus 6x. And then you're gonna have plus 6 and then equal to 1, you see. So if you take everything to the other side, you would have 1 over x here equal to, this would be like a positive 6x, and this would be a negative 6, and then this would be the plus 1 that you have there, of which you see you're still going to have 1 over x here. 6x is here. Negative 6 plus 1 is negative 5, you see. So you still have that negative 5, which is what we had here. And we said you're going to multiply by x on both sides. We did that, times this, times that. And then we put this into the quadratic formula, put this over. Let's see here, minus b plus minus b squared minus 4ac over 2a. Ish. This is not fun, eh? Do I have to check with the calculator again? Yeah, probably. Let me check again with these values in the calculator. See what could be the problem, you know. So I mean, like, as we're checking here, I mean, like, I think this should also give you the idea that whatever answers you get, right, like, don't be scared to check them, you know, because sometimes you may be thinking, I don't want to check it, what if it's wrong, and then now I don't know what to do. Just check it, because I mean, like, fun enough, depending on whatever the problem is here, you're gonna notice that it's probably something small. And then on your side, since you're just like viewing, you probably spotted the error a long time ago, and then I'm still just, it's the x values, brah, come on. I don't know how I got these answers. This sucks, man. This sucks, balakis. But anyways, oopsie, sorry. So the whole idea is, I think it's what I put into the calculator that's the problem. Yeah, that's the only explanation for these wrong answers here. It's because of what I put into the calculator. So on your side, you probably maybe, you know, put in the stuff in the calculator correctly. So on my side, I probably would have saved a lot of time if I just put the stuff correctly. Maybe I missed a negative somewhere, I don't know, but here I am. The other x value is, so the first x value, so this is this, and then the other one is, I think, a positive 1. Is it a positive 1? Yeah, it's a positive 1. The other one is a positive 1. Haibo, write a 1 winner. These are the two values. Let's check out the negative 1 over 6 1 and then the positive 1. So this one is technically going to be negative a third. Calculator. I already made a mistake already, so I might as well not do some funny stuff here. Negative 1 over 6. And then what do we have here? Minus 2. That's like negative 7. Negative 7 over 3. Okay. Negative 7 over 3, bruh, not the other way around. This one, 2 minus 2, that's a 0. 0? Doggo, a 0. Actually, let's test out this one. If x is a 1, and this is a 0. Oh yeah, it's going to be 1 minus 0, which is 1. Okay, those will work. If x is a 1, this is a 0. Oh yeah, I think these answers work. Because if x is a 1 and y is a 0, it balances out for both equations. So we shall take that one. We shall take that one. We have taken that one. Or we've taken these answers. They are okay. They work. Nothing crazy. Nothing major. Is good. Is good. We're enjoying life. Moving on. Let's see. The first term of an arithmetic sequence is negative 2. No, negative 1, bruh. Come on. And then it says the seventh term is 35. So A is equal to a negative 1. T7 is 35. All this being said, they want a value for D. The easiest way to get a value for D in this situation, since we cannot use T2 minus T1, we can just use the general term of what you call of our arithmetic sequence. Because in our general term, we know that our first term is -1. They told us that term number 7 is 35. So we can put n as 7, tn as 35, and we can just solve for d here. This is going to give us 6d. And then what do we have? The 1 can go over. That's going to be like 37. 37? No. Oh, this is looking freaky now. Dogo. Dogo. Let's see. 7 minus 1 is 6. Why does it look weird though? Like it literally just looks weird. Because h37 divided by 6. Dogo, no, I'm not. The answer. Why am I discriminating though? Well, obviously, I wrote 36 by mistake. No wonder, man. No wonder. I was seeing that something was really off. Yeah, it really just wasn't working out. But let's see here. Everything is looking fine. If we divide both sides by 6, we're gonna have here divided by 6, divided by 6. Yo, come on, bro. Right nicely, my guy. So many 6's here. The final answer is just gonna be 6. So okay, this was an okay equation. The next one out of 3, it says the number of terms in a sequence. We should determine the number of terms in a sequence if the last term is 473. So there is a formula here. Tn is equal to na, and then I think it's come on, bro. Snap, what's that formula again? I'm forgetting. The number of terms in the sequence. Determine the number of terms in the sequence if the last one is this. What is that now? What is that formula again? Is it a plus? Why am I even guessing though? It's something. I think it's n something with L. But let me see. Oh no, we're still dealing with this same sequence, dude. I don't even know why I'm struggling. But then Tn, right, is equal to a plus n minus 1d. So we should determine the number of terms in the sequence. This one, you see, I was overthinking it. So the number of terms in the sequence if the last term is this. So it just means Tn, we're going to make it 473, right? And then n is going to give us the position of this last term. Because if we get the position of the last term, we get the number of terms in the sequence, you see. So you see, I was confusing it with the Sn formula, where if you have the first term and the last term, you can get the Sn. I was confusing what we need here. So that's how, this is the formula I was thinking of, but we don't need it here, or we cannot use it rather. So the first term we got, they told us it's -1, and then our d we got, worked it out to be a 6. So this is like -1, 6 times n is like 6n, 6 times -1 is -1, and then what do we have here? Negative is like 6n minus 7. So this is like 400 and that. And then the 7 can go to the other side. So it's like 480. This is equal to 6n. And then divide both sides by 6. Well, the Mhlagazi is back, by the way. The electricity is back, people. It was gone for like an hour, which is like, okay, thank you for coming back, because we need you here. So this is like 80. Perfect. 2.1.3, the sum of the first 40 terms in the sequence. We need the sum of the first 40 terms. This is a quadratic number pattern. Wow, okay, this is interesting. Why is this interesting though? It just is, bruh, because normally if you need to work out the what you may call, normally if you need to work out the sum of a certain number of terms, it's usually easier to do, right, if you are dealing with like an arithmetic sequence or a geometric sequence. So this is a quadratic, what you call, no, I'm confusing it, bro. I literally, no, dude, yo, I was about to mess up real good. No, this statement is for the next question. Oh yeah, let me just remove this here, because I was about to do something very crazy, and yeah, that was not gonna be very Very nice. Let me just copy this, right? This actually goes with the next question, like the bottom part. Let me rub out the top part here for this one, and then for this one, let me rub out the bottom part, because I was actually like thinking, what is going on? But anyways, the sum of the first 40 terms, we can just use the Sn formula, right? S40, or rather Sn is equal to n over 2 a plus l. We might as no. We cannot use this one, because this one is if we're using the last term, if we're counting out everything. But then here, it's what again? N over 2, I think it's 2a here, plus n minus 1d. Why am I doubting this formula though? It's weird. It's like, Dogo, this formula, why does it look so weird? But I think it's the one. What am I saying? Why am I saying I think it's the one when it is the one? Yeah, it is the one. So sum of the first 40 terms, n is 40. 2 times a is a negative 1. But then you see what I'm doing now, right? I actually should just double check on the formula sheet, because, yeah, I mean, like, why not? Double checking on the formula sheet is the cheapest thing you can do. So just don't be arrogant, Don't be arrogant. If you want to fail, be arrogant. You'll get humbled. But anyways, let's put everything in the calculator here. See what we can do. 2 times negative 1. And then we have like the 40 there. Minus 1. Then we have the positive 6 there. 4,640. 4,640. Okay, let's just check the formula sheet for the thingy. I'm just checking the formula sheet really, because why not? Why not? So I just want to open up the formula sheet and then check what the formula sheet says, because I know the formula is right, but I'm just trying to give you the idea that just don't be scared to check your stuff. Just, so yeah, the formula is fine. So let's just carry on. Moving on, it says, write down the fifth term of the number pattern in this quadratic number pattern. So we have this quadratic number pattern, the one that's to write term number 5. So this one is not so bad. We can just, let me actually move this lower, actually. Let me do this. Zoop. And I need to remove this here. Like, yeah. Otherwise, we're going to confuse each other. So let's see. The reason I brought this down is so that I can just do this, But then, yeah, I feel like I just did the lazy thing here. Crop? I can crop and stuff. Yeah, of course. Let me do it here, because I actually need this for the next question also. But then, what am I doing? Oh well, let's carry on. So here it's what's going on here? Oops. Let's see. So for this question, for the fifth term, we need to find out certain things. You see, this minus this, 53 minus 75. What is 53 minus 75? It is giving us negative 22. 35 minus 53, it's giving us negative 18. Let's see here, negative 18, right? And then 21 minus 35 is negative 14. Okay, perfect. So let's see here. Negative 18 minus 22. So it's like negative 18 minus 22. Or minus negative 22. So you'd actually be adding, you see. So it's like a 4. And then negative 14 minus negative 18, you actually be adding. So it's actually going to be a 4 here. So the reason for getting this 4 is so that we can reverse engineer the whole thing, you see. You see, because this plus this gives you this plus this gives you negative 10. So negative 21 plus negative 10 would have given you what? 21 minus 10. Am I really using the calculator for this? Just for the vibes, man. Just for the vibes. So T5 is equal to 11. Perfect. The one that general term. So I mean, getting the general term is not going to be difficult here, because remember, we need this value, and this value. So what we know is that 2a is equal to 4, which is going to be divided by 2, because all you do is, yeah, this is equal to 2a, this is equal to 3a plus b, and then this number here is equal to a plus b plus c. You see, this number, and this number, you use those to get your general term, as long as it's specifically in the structure where this is term number 1, and this is the first term in the sequence of first differences, and this is the common difference. Divide by 2 on both sides here, we're gonna have a is equal to 2. Secondly, we're gonna throw a in there, right? So our a is a 2. So negative 22, that's like a 6 plus a b, negative 22. And then we have what? B, what is negative 22 minus 6? That's like negative 28. And then what next now? What is next? Oh, come on, Brody, come on. No, next is C. So to get C, we're going to have here 2 minus 28 plus C, right? Equal to 75. So what is this now? Negative 26. And then 75 plus the what? The 26. What do we get there? 75 plus 26, we is get 101. Okay. So obviously when you get these answers, right, just double check your formula by using one of the terms that you have and stuff. So for example, Tn here is equal to 2n squared plus Bn. Bn plus C. Perfect. So to test your formula, let's just put T3 and see if we're going to get 35. So let's see in our calculator. 2 times 3 squared minus 28 times the 3 there plus 101, right? This is giving us 35. Yep. Is the correct answer. So we can move on. Okay, it says determine the maximum value of the following number pattern. The maximum value of the following number pattern. Okay, maximum value, technically they just mean like the highest value. You say highest. Wow. Highest. So without us overthinking it, we need to find out what kind of a sequence this is. Is it arithmetic, geometric, quadratic? My suspicion is that it's quadratic. That's just my suspicion. So we have to say this minus this, this minus this, and this minus that, you see. So let's do it. So negative 25 over 5. So negative 21, right? Negative 21 over 5. We're subtracting. What are we subtracting? We're subtracting negative 7. So you'd technically be plus because the minus and minus be plus. So let's see. What is next? 14 over 5. This minus this is 14 over 5. And then negative 7 minus that value there. So let's see, negative 7 minus that value there. So don't forget to put the negative in the calculator so that it changes it to a plus. Because you see this, a negative minus a negative, you're going to be plusing this value. So that's going to give us, this is giving us 18 over 5. So the more this is happening, the more I'm thinking, yeah, we're probably definitely dealing with a quadratic number pattern here. Because normally if they ask for the maximum value, 99% of the time you're going to be working with what you call with a quadratic number pattern. Because if you check here, these have a second common difference. You see, this minus this gives you a negative. Bro, just checking the calculator. Why are you trying to be a hero? Don't be a hero. Don't be a hero. So that minus the 18 over 5 is gonna give us negative what? Negative 4 over 5. And then this minus this is giving us let's see here, 18 over 5, right? Let's subtract this thing here. 22 over 5. That's giving us another negative 4 over 5. Okay, so it's definitely a quadratic number pattern. Now, logically speaking, what can we do here? So they're asking us to determine the maximum value of the sequence. So if it's if they're asking me for the maximum value, right, it basically means that whatever this sequence is, the numbers are going to increase and then they're going to reach a certain value and then they start to decrease again. So if you look at it nicely, you see a negative 15 here, the next value, let's see what this number is in the calculator. Let's see, negative 53 over 5. That is a number that is bigger than negative 15. And then obviously this is bigger and then it's getting bigger as well. So for 4 marks, we kind of almost have no choice but to like manually work this out, because it looks as though really, bro, I mean, like, okay, no, I don't think manually working it out is a bad idea, because I don't know, for some odd reason I'm thinking to myself, I don't know, but let's just get the general term for this sequence and then get the position of the highest number using the turning point formula. So yeah, me wanting to like just finesse this question and just do it manually, I think that's just being lazy and also a bit risky. But I do feel as though what we're gonna do, the 4 marks is really not enough, eh? But yeah, you just gotta do what you gotta do. So let's just get, I think the safest way is to get the general term of the sequence. After getting the general term, you can then just work out this formula. You see, n is equal to minus b over 2a. This will always give you the position of the highest term. So we actually just need a and b and not the whole thing actually. So let's just get a and b, because remember, a quadratic number pattern behaves just like a parabola. So here 2a is equal to negative 4 over 5. So we're gonna have here what is this now? A is gonna be this number here divided by 2, right? So our a value is negative 4 over 10, which is just negative 4 over 10 is giving us negative 2 over 5. And then our b value, let's see what we're going to get there. Plus b is equal to what? 22 over 5. Okay, so let's see here. In the calculator, wait, this times this is going to give us negative 6 over 5 plus b, 22 minus 5. And then this goes to the other side, right? 22 over 5. Just going to add here 6 over 5. What is this going to give us? 22 plus 6 is like 28 over 5, right? Perfect. Whew. Yeah, as you can see, but then still, dude, this is just going to give us the position of the highest value, but then we still have to get the highest value. Yeah. Wait, let's see. What is this value? Negative 21 over 5. Negative 21 over 5. Yeah, it's still higher than that one. Now let me just carry on. So since we've already invested time in this question, right? Like, let's just carry on and see what the position of the highest value is. Because yeah, let me actually put an arrow here to say what we're doing here. This here is position of highest value. So the reason why we're saying this is the position of the highest value is because this is a quadratic number pattern, because it behaves like this. The numbers go up and then they go down. If they had asked for the minimum for the minimum value of in the sequence, right, it just means our sequence would have been going down and then up again, meaning it would have it would draw something like this, you see. So the idea is, whether they're asking for the minimum value or the maximum value, we're still going to do the same thing. We would still do the same thing. But anyways, let's see here. So here n is equal to a minus b over 2a, right? So our b value here, we have like 28 over 5. So with the negative, that's going to be there. And then negative 2 over 5. Ooh, yeah, so I think this is going to help to see if, yeah, let's just get it. Let's just put this in the calculator. Negative 28 over 5 divided by 2 times negative 2 over 5. Okay, what do we have there? Negative 28 over 5 divided by that, what are we going to get? 7. Okay, so the 7th term is the maximum value. So this is just 1, 2, 3, 4. You're now 5, 6, 7. Woo, so we have to get 3 more terms. But instead of doing it manually, I think we might as well just get the sequence, Let's just get a value of C also. But then the more I'm looking at this question, the more I'm thinking to myself, was there really an easier way to do it? Since the 4-mark question, probably there was, but probably there is, but since it's not in mind right now, we have already invested time, we might as well just finish off and get a value of C, right? So here our A value, we got negative 2 over 5, right? So negative 2 over 5. Our B value, we have 28 over 5. C, we are working it out. And then let's see what we're going to get there. So our C value, if you put everything in the calculator, these would go to the right side, right? So here you'd have negative 15 plus 2 over 5. And then here minus 28 over 5. So that's what is it going to give us now? I'm just double checking so that I make sure we do put everything in the calculator. That's giving us negative 105 over 5. Whoo-wee. Wow, at least I gave myself space down here. So let me actually write down there so that, you know, things kind of like have some kind of a flow to them. So with this being said, we can now get our Tn. So Tn is equal to, yeah, this is fine because our A value is a negative, which is good because you see this is a frowning face. So this is Tn for, what is our B value? Plus 28 over 5. And then our C value is negative 101 over 5. So we are looking for T7, you see. So T7 is going to be negative 2 over 5. And then we're going to have here 28 over 5. Oh, I forgot to put N here. There's a 7 there. 101 over 5. Whew. Here, let us see what this value is going to be. So obviously you may be thinking to yourself, why so many steps? Yeah, it is what it is, you know. In this situation, oh, squared. Crap, bruh, come on. Yammer. Apologies. This is the general term, right? Because it's a quadratic number pattern. So it's going to be n squared and then n alone, and then something without n at all. So remember, all this is me doing it in the fly. You know, I'm not like looking somewhere for the answers or whatever. I'm like figuring out the paper as I go. So I'm definitely bound to make these silly mistakes, but when I see them, I'll just correct them. You see, so this is giving us negative 3 over 5. Negative 3 over 5 is the highest value, which kind of makes sense because that's like negative 0.6. So it kind of shows that after negative 0.6, you're going to probably get something lower than that. Let's test out n as 8. Let's see what it's going to give us in our calculator. It's going to give us negative 1. Negative 1 is lower than the negative 0.6. But so to test our formula, let's put n as 3. Let's see if we get a negative 7 there. So let's see here, n as 3. Put that there. N as 3. Yep, negative 7. So everything works out. Okay, let's move on. 2.2.3. So the maximum value is negative 3 over 6. So max value is negative 3 over 5. For 4 marks, they say determine the maximum value. Oh, Baba. Did I just put the same question twice? Hi, man. Come on, man. Come on, Baba. See previous question. Lol. See previous. Why am I even writing this? Like it's so unnecessary. Question number 3. Here we are. What does it say? It says, consider the following geometric sequence. So they told us it's geometric. So fortunately, they've told us what we're dealing with. For 2 marks, they said calculate the 10th term of the sequence. Okay, so Tn is equal to A times Rn minus 1. So R is going to be T2 over T1, right? So let's see here, 256 over 1024. Is that not like a quarter? You know, a quarter? I don't know. I'm going to have to find out. Is a quarter. A quarter. Sparkle. But anyways, let's see. A is what? A is 1024. That's a quarter there. A quarter. Now I'm getting hungry now. What is N? N is 10. So we're looking, it's up there. So we're looking for T number 10. So that's why we made N a 10 there. We have A and we have the value of R. So this we can just put into our calculator, This formula is on your formula sheet. So you must know what it is used for. Otherwise, it's going to be a problem. So this is 1 over 156, which kind of makes sense because these are just getting lower and lower and lower. The next question out of 4. So this is how you interpret this question. They're saying you should add up terms starting from where P is a 0 until where P is 8. This question is quite interesting because with this kind of a question, you want to be careful. You really want to be careful because with this kind of a question, you have to remember that all sigma notation questions, they're in this format, right? They'll always have the general term here. General term. And then this is giving you where you're ending. This is giving you where you're starting, you see. So where you're starting allows you to get a value for A in your formula. Because remember, because this is geometric, the moment you see sigma, you should be thinking of the Sn formula. Sn. And because the value of R here is, as long as R is bigger than -1 and smaller than 1, it's easier for you to use this formula. You see the one where the 1 starts, because the other one where these are swapped around and where these are swapped around, it's easier to use that one where your value of R is like a big value, or a value that's not between this -1 and this positive one. So since we have a value of R that's a quarter, this is your best bet. Now your value of A is always what you get when you throw this into your formula. You see, that's your value of A. So meaning in our case here, our value of A is what you get when you put 0 into your formula over there. You see, so A is going to be 256, 4 to the power of 1 to the power of 0. And this is stuff that we mention all the time in the online courses, especially in the sequences and series course, you see, which you can get on the website. The link is in the description. It says here, this is just 4 times this. Oh, this is funny. Hey, is this value? We already have it. That's kind of weird, kind of awkward. Hi, but hey, don't take any chances, because sometimes, yeah, some of these things, they're not very straightforward, but this one is kind of straightforward, I guess. So A is 1024. It's always good to double check what your value of A is, like literally. So our value of N is, okay, so N, oh yeah, I think this is where things get interesting. N has a formula. It's always where you're ending minus where you're starting plus 1. This is where people are probably going to lose marks because you're ending at 8, you're starting at 0, then you need to plus a 1. That's just the formula for N when you have a sigma question, like literally. So this is 8 plus 1, right, which is 9. So this is where things get really, really important because, yeah, I'm pretty sure if you did this paper and you're looking at this question, you're probably like, oh yeah, that's probably why I lost my mark. But anyways, here, let's see. So we have N, we have A. As long as we have A, we have N, and R is just, to get R in this case, I mean, like without overthinking, we know that R is a quarter. So, but then you may be thinking, but what if it's not a quarter? Like the easiest way to double check it is, we already know that R is T2 over T1, you see. So you can just put T1 in your formula here. You're gonna have 256, 4 with 1 minus 1. And then here, this T2 rather. T1 is going to be 256, 4 with 1 minus 1. So it's just us putting the stuff into the formula. So putting that into the formula, let's see here. 256 on top there, 256, open bracket, 4 to the power of 1 minus 1, close the big bracket, and then here down here, 256, 4 to the power of 1 minus 2, no, 1 minus 1, the top is supposed to be 1 minus 2. So I'm just making sure I put stuff in the calculator properly here. Otherwise, we're going to cry, and crying it's not good, crying is expensive. Save that for, yeah. Anyways, so R is definitely a quarter. We already knew that, but just trying to keep everyone happy. So S9 is going to be equal to A is, we said 1024. R is a quarter. N is a 9. And then the whole thing here is like 1 over a quarter. And then what? What you gonna do? What you gonna do when they come for you? Hey, you're gonna fight them, Baba. You're gonna fight them. Or you're gonna run. You must stand and fight. Unless they have, weapons, then hey, just run. It's not worth it. Life is precious. Let's see. This is giving us 87,381 point. Over 64. This kind of looks a bit shady, but hey, it looks fine, because our numbers are not very exotic either, So because look, 1,000 and something, if you add this, you're gonna get 1,300 and something. And then if you add the Togo, no, nah, I'm not liking this answer, like literally. Let me actually see something. Oh, okay. Wait, what is plus 32? This answer is wrong. This answer can't be right. But why, man? Why are you doing this? Why are you doing this? Let me just double check again, 1024. Let's see here. Delete. 1 minus a quarter. And then to the power of 9. And then 1 minus a quarter. Because I'm not liking that answer at all. Uh-oh, it's the same one. Come on, man. Come on, this doesn't make any sense. 1 minus r to the power of 9, 1 minus r to the power of 9. Let me have it swapped around and see what happens if we get the same answer, because this is kind of not nice. So you see, we have an answer, but yeah, the answer is not satisfactory, The reason why the answer does not seem to make any sense is because, yeah, the sum to infinity is basically a way of saying that if you add, let's say, the first term plus the second one plus the third one all the way to infinity, this is the highest number that you're going to. Oh, wait, no. I think it works out. It's me that's confused. I was using the wrong numbers. Because technically, if it's like 1024 plus 256 plus 64, the next one is a quarter of 64, right? Which is like 16. Oh, and then a quarter of 16 is like a 4. Oh, yeah. And then a quarter of 4 is like a 1. Oh, yeah. Oh, no, this is 100% correct, man. I was just, yeah, my brain was doing the wrong thing. Because in my head, the next number I added from here was like a 32, which is wrong. The next number from here is actually a 16, and then the quarter of that is a 4, quarter of that is a 1, and then, going on and on and on. So if you add up 9 terms, if you add up the first 9 terms, right, it's going to be 1, 2, 3, 4, 5, 6, 7, and then 8, 9. So the next two values here would have been, let's see, a quarter of a quarter times a quarter would have been 1 over 16. Let me actually write down the actual numbers so that you can see where I'm going here. 1 over 16, and the next one would have been like 1 over 64. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 values, and they roughly give you this. I might as well even delete this because, yeah, why use decimals when you have the actual thing? 3.2, the first 2 terms of a geometric sequence are this and this. Before I even look at the question, you don't want to work with these like this. You want to simplify it. This you clearly have to factorize. This you also have to factorize. It says determine the values of t for which the sequence will converge. So the sequence will converge where r is bigger than -1 or smaller than +1. These kinds of questions, we work on these in the course platform like all the time. Like, let me even show you an idea of what I mean, you see. So remember, on the website, right, all the courses have a PDF file. So for example, here I'm searching for the PDF file of the, what you call, of the sequences and series course. So this is the PDF file, right, for the sequences and series course. Now, literally, if I scroll down somewhere within this course, you're gonna find out that there are definitely questions that are gonna be asking you things like, where is the sequence converging, blah, 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 blah. Like literally, let me just try and look for it here. Give me 2 seconds. So everything that you see here, right, is stuff that would be written out like while explaining it. It's just like what we're doing in the question that we're working on now. Let me just see here. You see something like this, you see. It says here, for which values of x will this exist? This is the same idea as asking for which values of something will the sequence converge. But then we're looking for the exact words, right? Where we talk about where the question will have where will the sequence converge. So let me just try and see if we can find one here. Come on, there has to be. There definitely is. I'm just gonna find it. Let's see. So moving on. Let's see here. Determine common difference to consecutive that. Determine the this. Let's see, arithmetic sequence. Oh wait, I'm already at the end here. Calculate the value of this. Calculate the 12th value. Explain why this sequence converges. You see, it converges because r is between -1 and 1. You see, that's the main reason why a sequence converges. So as I was saying, right, that's like stuff you're gonna find in the sequence. You see what converging means and what to do. So here, as we said, whatever we're gonna do here, we have to definitely factorize both of these. So factorizing this, yeah, this one is gonna be a bit crazy, but I think 3 and 3 will work, because for this one, technically speaking, if you take out a negative here, or rather, let's factorize this one. Factorizing this one, right? What I would do is negative t squared times negative. So normally when I factorize a question, there are two, the cycle, the crazy way to do it now, you take this and this, that's going to give you 9t squared. And then you want to break down the 9 to get factors of 9 that give you a 6. It's going to be 3 and 3. But then to get a minus 3, I mean, to get a minus 6, it has to be a minus, to get a minus 6, it has to be minus 3, minus 3. And then I just place the middle part with these two here, like that, you see. So this negative t squared is the front number. These two have replaced this, because remember, negative 3t minus 3t is still going to give you minus 6t, and then there's a negative 9 here. So here we can take out a common factor, right? So a common factor here, it looks like we can take out negative t. So if negative t goes out, you're going to have here t, and then here plus 3. Same way, you can take out a negative t. If you take out a negative t here, no, a negative 3, bruh, come on now. Come on, my guy, come on. Take out a negative 3 here, you're gonna have negative t left. Ooh, this one is kind of not gonna work. Baga, come on, man. Snap, crack, pop. Let's see here, negative. If you multiply inside, it will be giving you this. If you multiply inside, it will be giving you that. If you take out a negative 3 here you have to leave a positive t, which is fine. I'm trying to factorize nicely here. Okay, and then this times, this would have to be a positive 3. Oh yeah, what am I saying, bro? It's working out fine. So yeah, then you see these two brackets look identical. So you can take that out as a common factor. And then what you have left there is technically negative t minus 3. Perfect. I feel like them using t was just them being so mean, because working with variable t, it's not the nicest thing. So this factorized gives you these two brackets. The reason I factorized is because, I mean, like normally if you're dealing with an expression that's just all over the place, the best thing you can do is to factorize it. Same here, you see. let's see. So factorizing what we have there, we're gonna have what are we gonna do? Yo. Ay, ay. Wait, they say this is the first two terms, so we know that this divided by this is r. Oh well, it is what it is. Let's see, because yeah, we kind of do need to factorize this. So factorizing this, I think I would recommend using what is this, synthetic division. So the fortunate thing with using synthetic division to factorize is you at least firstly need one factor. You can usually get that factor using trial and error. So meaning in your equation, you can even put something like, like a 1, and then test out if 1 is going to make the equation equate to 0. Or let me take it slow. Let's factorize this thing here. We want to factorize t cubed plus 9t squared. I should have given myself maybe 2 pages here, because hey, I don't know if it's gonna work out, man. But let's factorize this expression. So we might as well work on how to factorize, So the first thing you do is you want to firstly get a factor of this equation. You wanna get a value of t that will result in this thing here being a 0. You see. So what you can do in your calculator is you can just put in values for t like -1, -2, or 1 or 2 to see if those numbers work. So because this is all being added up together, I think putting a negative is going to work better, because already here you see -1. If you put it here, that's like -1, right? Because -1 cubed is -1. And then here, if you put a -1, it would have been 1 squared. So that would have been, but you see, doing it in your head is just not going to work. So it's better to use your calculator. So what I normally like to do in the calculator is to use the table method, like to put this equation in the calculator. So in your calculator, you can press table, and then you can just put this equation. So you can just use the variable x, it's fine. So x cubed here in the calculator plus 9, and then alpha x, that's going to be squared, plus 27 alpha x, and then plus 27 as well. So it's going to give you an option to put another equation. We don't have another equation, so you just put, just press equal to in the calculator. And then where it's starting, it's asking you to start, right? Choose, what are you going to choose? I think here choose -2. Let me start at -2. And then end at +2. But then for this one, in terms of the step, right, choose a half. Just I think, yeah, I just have a good feeling about using a fraction. But yeah, from -2. So now if you press equal to, you can just check. You can just check amongst your answers if you're gonna get something that's gonna give you a 0. Unfortunately, none of these are giving us a 0. So kind of have to start again. And excuse me, I couldn't move the mic because the mic is like fixed. It's stuck. But anyways, we have to change these numbers. Let's start maybe at -8 and end at +8. And let's make the step 1. So let me try that. So I have to put everything back in the calculator here. Cubed plus 9, and then what? Alpha t. If this doesn't work, then we're gonna have to finesse the question. We're gonna have to use the this other part here. It may help us. But let me see here. Plus 9x plus that plus 27 equal to that. Yeah. So let's start at -8. Let me change this to -8. Let's end at +8. If you make your step a half, it's not gonna work. It's too, yeah, your calculator cannot take that much. So start at -8, end at +8, make the step a 1. So here, let's see if something is gonna give us a 0. -3 works. So here we're getting that t is a -3. If you put a -3 in here, this will be equal to a 0. So what that allows you to do is we're now able to factorize this using synthetic division. And this is how synthetic division works. This -3 that we have, right? You're going to put -3 here like this. You're going to write out the coefficients of your expression. So you have to make sure that this is in standard form, meaning it has to have 2, 3 here, 2, and then 1, and then nothing. You see, t to the power of 3, t to the power of 2, t to the power of 1, and then nothing. It has to be in order. If let's say this was not there, then you would need to replace. So what I mean is you have to write these coefficients, right? 1, 9, 27, and 27. If one of these were not there, you would need to replace it with a 0, because this has to be in order from starting with something here, something there, something here, something there. If this is a 3, right, then it means you're going to need to have 1, 2, 3, 4 terms here. So if let's say this was missing, then you would need to put a 0 in its place, and then 27 next, and then the 27 afterwards there. But anyways, on the main channel / Bright Young Brains is the main channel. This is why I post, like, you know, shorter tutorials and all that. You'll see there's a tutorial there on synthetic division in the functions and graphs playlist. But anyways, what you do is you write this out, you leave a line open, and then you're gonna drop this number down. Gonna drop this number down here, and then you start. So all you're going to be doing is multiplying and adding over and over again. You're going to be multiplying stuff and then adding, you know, over and over again. So here, 1 times -3 is a -3, and then you add these up. 9 plus this is a 6. Then you start again. 6 times -3 is -27. Then you add this up. That's a 0. I lied. What is that, bruh? No, it is a 0. No, I don't think it's a 27. Bro, come on, man. Come on now. This times this is -18, bruh. What did you just do? Wow. I think this gives us a 9. Or rather, a negative. Yeah, is it a positive 9? Yeah, a positive 9. And this times -3 is going to give you -27. And then if you add this, gives you a 0. I was already thinking of a 0 because my brain was already at this step, but I was still here. The reason I was thinking of this is because this number always has to be a 0. That's how you know your answer is correct. So what this does is this is giving you, so as long as t is equal to a 3, right, it means that when this is factorized, your first bracket has x plus 3 because of this -3 there. Your second bracket has these as the coefficients. You see, it's going to be x squared plus 6 plus 9. So this you can factorize, because factors of 9 that can give you a 6, it's going to be 3 and 3. So 3 and 3 there. So 3 plus 3 is what gives you a 6. And then 3 times 3 is what gives you a 9 there. So this is quite interesting. Or is it? Yeah, it is. So this whole thing factorized, right? It's just going to be 3 brackets that look like this. Oh no, we're working with t, bruh. Oopsie. Hey, I'm just so used to x that I did not even consider. I didn't even think about that, the whole t thing that we're using there. So this is just going to be t, and t. Yeah, you see what they're trying to do here, trying to confuse us with these random t's here flying around. But anyways, it is what it is. So as long as this is factorized and as long as this is factorized, this question is going to be easier, because determine the values of t for which the sequence will converge. So if your sequence is going to converge, you need a value of r. Now this is t1 and then this is t2. Remember, r is equal to t2 over t1. We know that this is equal to t2, but then t2 we know it's over 2. Remember, we were just factorizing this on top. The over 2 part, we didn't have to consider it until now. You see, whatever we did, we're just trying to say this is t2, right? And then t1 is, what is t1 again? This. It's t plus 3 and then minus t minus 3. But unfortunately, it looks like you can take out a negative here as a common factor. If you take out a negative, you can put that right in the front there. And then you're going to have here t plus 3, like that. So this becomes a positive t, this becomes a positive 3. So you have t1 and t2. So life is good, eh? Because now we can say, therefore, r is equal to this whole thing here, where we have 3 of them over, here we have 2 of them. You see? And then r is equal to t plus 3, the whole thing over negative 1, you see? Which is technically r. No, bro, come on, man, come on. R is equal to negative t plus 3. So since we now have a value of r, it's easy to work out our question, because remember we said for a sequence to converge, r has to be between negative 1 and 1. So here we can say, therefore, we know that r has to be between negative 1 and 1, right? So we have to drop r there. What are we going to have? Let me not write too low here. Otherwise, this thing is going to get chopped off. It's going to get chopped off, hey? So we can say, therefore, we said r is between 1, negative 1. So a sequence converges wherever r is between this and this value. So whenever you ask questions like these, right, you have to solve this inequality after you have a value of r. So this is our value of r. So here we can put here negative 1, and then here negative t plus the 3 here. And then let's carry on, you see. So this here, we can multiply the negative inside, and then what you get? We want to solve for t, right? So the 3, we can add 3 everywhere. It's going to be negative 1 here plus 3. If you add a 3 here, it's going to go away. It's going to be minus 3 plus 3, right? So the minus 3 and the plus 3 cancel each other out. And then here, let's see. This is going to give us what? Negative 1 plus 3. What is negative 1 plus 3? Negative 1 plus the 3 is, I think positive 2, bruh. And then here, 1 plus 3 is a 4. And then we can divide everything by a negative. Remember, if you divide by a negative, your signs have to flip over. So this is going to be negative 2. It's going to be negative 4. And then your life is going to be good. So that's the answer here, you see, because the question said determine the values of t for which the sequence will converge. So yeah, that's how it's done, you know. So you see, you can see here for these kinds of questions, you can see you really do want to sign up for the online courses, because yeah, it's gonna change your life. It is going to change your life, people. Like legit, I kid you not. Anyways, so let's move on to question number 4. Question number 4. Okay, so what do we have here? It says the following. So diving into functions and graphs now. This is clearly an exponential graph. They said it passes through this point over here, right? And then they say we should calculate the value of a. So calculating the value of a is pretty straightforward, because we have a value to put there where x is, we have a value to put there where y is, which is right over there. So where y is, that's just a 10. And then here we have a with 1 over 3. X is negative 2, right? Okay, there we go. Gosh, why does my 2 look so weird? Come on, man, come on. There we are. So with all this being said, right? Bro, come on, bro. Your 2 can be better than that. Come on. There we go. So, how many seconds have we spent on this negative 2? Solving for a here, we know that you have to make use of, you can just use your calculator for this value here, you see. Because in your calculator, let's see, 1 over 3, the whole thing to the power of negative 2. That's going to give you a 9. How lovely. There's a 9a here, plus 7. And there's 10 over here, right? So the 7 can go over. 10 minus 7, 9a. And then this is going to be a 3. Perfecto. So the whole thing here, we're just going to divide by 9 on the right. And then I'm just going to divide by 9 on the left. So this is a here. This is like 1/3. There we go. A is a third. Nothing crazy, nothing major. For 2 marks here, they say calculate the coordinates of the y-intercept of G. So getting the y-intercept, we already know that x is equal to 0. You see, because for the y-intercept, it's the value where the graph cuts the y-axis. So in our equation, since we now know that a is a third, what we know is this is the equation of g of x. G of x is just a third, and then a third again. Was it negative x or x? Yeah, just x there, and then plus 7. So obviously the plus 7 is the asymptote, but that's irrelevant for this question. We have to make x a 0. 1/3, x is a 0. Anything to the power of 0 is a 1. So this is like 1 times a third, which is just a third, plus 7. Don't even bother yourself. Don't bother yourself, eh? Just put it in the calculator. So this is giving us 22/3. 22/3. Okay, 4.3 says this is h of x, right? They say describe the translation from G to H. So this is not too much of a difficult question since it's just out of 2, right? So looking at the equation of G, right, if you compare it to the equation of H, the two things that are different is firstly this plus 7 here and this value here. Now the big idea is when they speak of a translation, they are talking about a movement, you see, from left to right or from top to bottom. So for you to be able to determine the translation, we need to think of the standard form of an exponential graph, of which the standard form of an exponential graph looks like this, you see, where we need to have a value for P here and a value for Q. So fortunately with this question, I mean, like the way it's set up, it's already giving us a lot of information, because this here is to the power of 1, right? Now the basis is the same, so you can add the exponent. So actually G of x, you can look at it as 1/3 with x plus 1. So what this is going to do is it's clearly telling you that from G, for you to get H, your graph is going to be moved 1 unit to the left and 7 units upwards, you see. So here, describe the translation. So we can just say G was moved 1 unit, from x plus 1, right? Here we have to minus 1. Oh yeah, so it's actually movement 1 unit to the right, because here we have to minus a 1 for you to end up with just x. So G was moved 1 unit to the right, and then since this is a plus 7, for you to get a 0, you have to move it 7 units down. So G was moved 1 unit to the right and 7 units down. There we go, easy marks. Describe the equation of the inverse, determine the equation of the inverse of h in the form y. So the equation of h, we already know it is just equal to a third to the power of x. Getting the inverse of this graph, this you make it equal to x, the exponent you make it equal to y. Now anytime we want to isolate an exponent, you isolate it and then you make it equal to log. Whatever the base of the exponent was, you make that the base of the log as well, and the value that goes here will just be whatever this was. So this is not a base for an exponent, no. The only thing is the value that goes here, and we call it the base of the log, and then this here is just in the same level as the log there, you see, and then that's your equation. 2 easy marks. Let's move on to question number 5. Here we are, question number 5. It's quite an interesting question, this one. But it's a hyperbola, right? So with this hyperbola, they say the following information of G is given. They're asking us for they told us the domain. Okay, don't mind this here. This was just from the question that the paper that I got. So don't mind this. I should have actually cropped it out. But anyways, it is what it is. G of x, they say this is our standard form. The following information of G is given by this. So they say it here, the domain x is element of R, but then x is not equal to -1. So this asymptote is correct. And then here the x-intercept at k is this coordinate, the y-intercept is this one. And then they said here, show that the equation of G is given by this. So if this is a negative, it means that this would be somewhere there, and then, but anyways, we're gonna draw it now, it's fine. We'll draw it just for the vibes. So the thing is, right, what we know is this is the equation given. They told us that x cannot be equal to -2, so that's already the asymptote there. So if x cannot be equal to -2, it means that down here we have to put x plus 2, because it's always the opposite of what you have in the actual equation. So with this being done, we have two coordinates that we can use to work out a and q simultaneously. The first one is this one. So the y value here is a -2. The x value is a 0. 0 plus 2. So this is the equation, right? So we can isolate q, So this is just -1/2. This is like a over 2. Wait, what am I doing? I need to move this to the left, bro. So we're gonna move this to the left. This is like a over 2 equal to q. This you can just write as -1 minus a, the whole thing over 2. There, so this is one equation, right? The next equation, what is the next equation? We have to put in the value of k. So x value is a 1, y value is a 0. So y value is a 0. And then this is like x value is a 1, right? So it's like 1 plus 2, then plus q. Perfect. So since we know what q is, we can just actually throw a value of q over there. So this one, we're going to have, therefore, 0 is equal to a over 3. And then, let's actually isolate q here so we can just make them equal to each other, It's going to make our life much easier. So this can go to the left, and this is equal to q. So both equations here are equal to q, right? So here we're going to have, therefore, we can label this equation 1, equation 2, and then what we have. So here we have equation. So here let's just do this, right? Come on. Equation 1 equal to equation 2. How's that going to end up? Let's see here. This is just -1 minus a over 2 equal to -a over 3. And then let's just cross multiply. So we're going to have a -2a. 3 times this is like -3 minus 3a. If you multiply 3 times this whole thing here. Whew, okay, everything on one side that has a, so it's going to be plus 3a here, -3. This is going to give you a positive, a positive 1a, right? And then a is -3. So you've got an a is -3, perfect. So for q, we know that q is equal to -3 here over 3, which is going to be, what is the q value going to be? Positive 1, which is what this is saying. You see, this is correct. So the graph is actually gonna, the asymptote is actually gonna be here at what you call it, -2. The other one is gonna be somewhere here at +1, right? But then because this is a negative, right, it means that it has to be here and it has to be somewhere over there, you see. Because if it's a negative here, it means that, this is a negative and then plus, negative plus, you see, which makes sense. But anyways, let's move on. Maybe they might ask us to sketch it, but I don't think so. It says, write down the range of the graph. So the range is, you see, this graph can go all the way up, it can go all the way down, but it cannot touch +1. So the range here, you're going to say y is an element of R, but then y cannot be equal to 1. Determine the equation of H, the axis of symmetry of G in this format. So they want us to get the axis of symmetry where the gradient is a positive. So this is important, you see, because with an axis of symmetry, it will always either have a positive gradient or a negative one. So our axis of symmetry is basically a line over here or a line over there. So the line that has a positive gradient, right? The positive axis of symmetry, the gradient is always a 1. If we're talking about the negative one, then the gradient would have been a -1. Let me repeat. anytime you need to get an axis of symmetry, your gradient is either a positive one or a negative one. You see, so here we're working with the one where the gradient is a positive one. So this we already know. Now the axis of symmetry will always pass through the point where your asymptotes meet. You see? So this is just x value -2, y value 1. So x is -2, y is a 1. So we can put here x. So we have -2, 1. Y is a positive 1. X is a -2. So we're trying to get the y-intercept here. But anyways, the easiest way to just, get the whole thing done without like wasting any time is to just use this format. This format allows you to just jump straight into getting your equation, you see. So here we have the y value here is a -1. I mean, it's a 1, right? So you throw it there, it will be a -1. And then we have here our gradient is a 1. Our x value here is a -2. So if you put a -2 there, it's going to be +2. And then let's solve for y here. We need to make y the subject of the formula. So this is like y, x +2 and +1, x +3. Fantastic, my guy, fantastic. Okay, so it seems like we're cruising nicely. But 2 marks, write down the coordinates of k, the image of k reflected over h. Well, yeah, so here we have to be careful, right? We might as well just draw the graph, because like, why not? Like, why is he bloody darn hell not? Wow, dude, wow, that's so unnecessary. So this is the equation of g, wait, what? H, where is h? Oh, wait a minute. H is the axis of symmetry, right? But then the thing is, we have to consider the graph of g for this statement, and you'll see why just now. Just give me 2 seconds, eh? Give me 2 seconds to write out the equation and 2 seconds to draw the sketch. Let's just redraw it, because me redrawing the sketch, it'll make your life so much easier in terms of like, understanding the whole shandies here. So we have our asymptote over here, right? It was -2. The other one is like over here, +1. I don't know, I'm making these so small. So much space and I'm making it so small. Like, wow, look at that. Wow, bro. Come on, me bro. Make it bigger, man. Make it bigger. Use the space. Don't be scared. Anyways, we have a big space here, and it's a bit too big. But it is what it is. So our axis of symmetry, right, the positive one, looks like this. And what we also do know is that this is the point of contact. This point of contact is -2, +1, like that. So as long as we know that this is the point that our axis of symmetry passes through, let's look at where k is. Where is k? What did they tell us about k? They told us that k is the x value is a 1, the y value is a 0. So let's see. X value is a 1, the y value, wait, say that again. Where is k? X is a 1, y is a 0. Oh, so it's like here on the x-axis. So this is k, 1, 0. Now if you're gonna reflect it about this line here, the one thing this line here, right? If you're gonna reflect it about this line, the one thing you have to consider is the what you may call the line that it passes through here. This is what's important. It's kind of strange to put it that way, but it's just how it is, This point here, all you have to do is you have to measure, you have to think to yourself, okay, fine, from this, right, to go here, it's technically 3 units to the left and then 1 unit upwards, right? You see 3 units to the left, 1 unit upwards. So because you now know that this is just 3 units to the left and 1 unit upwards, you know that this reflection, right, it's technically gonna be somewhere over here. Like if you look at it nice, just look at it nicely. This point, if you reflect it about this line, this point here is going to be like somewhere over there. Like if you think of it nicely, this point is going to be like somewhere over there. Let me actually put that point so that you can see the logic behind what I'm about to do. So this point, if you reflect it about this line, remember it has to be a mirror image of itself. So whatever this is here, we know that the point has to be, whatever this distance is from the line, it has to be the same distance on the other side. So our point is going to be like somewhere over there. Now, if you look at it logically, right, this is not even something that is difficult to understand. If you're looking at it nicely, this distance here, this distance of 3 units, right, these 3 units in this direction is actually going to be from this point 3 units upwards. And then this 1 unit upwards is going to be 1 unit to the left from this point. Because this point here is the point that you're going to use to help you work out the reflection from here to there. You see, the 3 units distance here, you're going to say 3 units upwards from this point. And then the 1 unit distance here, you're going to say 1 unit to the left, you see. So if you think of it nicely, from here, 3 units upwards, that's going to give you a y value of 4, you see. So the y value is a 4. And then 1 unit to the left from -2, that's going to give you a -3. Whew, okay, perfect. That looks fantastic. It's all good, is it not? Yep, it is. So anyways, this is where the new value of k is going to be. So with the next question, we are going to have another party. Okay, let us begin. Let us begin. Let us begin. What does it say here? It says the following. Question 6. What do we need? Question 6 says the sketch below shows the graph of f of x. It's a negative hyperbola. No, parabola, my guy. We just dealt with the hyperbola right here, man. Right here is a hyperbola, this one. Actually, Mr. being extra. Like, it's just a parabola. This is the equation of the parabola. And then this y value is a 7. The value of g is -5 and k. Okay, interesting. And then they said a and b are the x-intercepts. Okay. So they said we should get the coordinate of e, which is the turning point of f, for 3 marks. Well, let's find out if our friend had gotten the right answer. I think they did. But anyways, let's see. So in terms of getting the turning points, this is a parabola, right? But it doesn't matter. Whether it's a parabola or not, the easiest way to get the turning point is to just use differential calculus, you know, because differential calculus makes the world go round. So we're going to differentiate and equate our equation to 0, because differentiating gives you the gradient equation of your graph. So once we have the gradient equation of our graph, what we're trying to do is we're going to make the gradient as 0, and then we're going to work out the x value where that gradient is a 0. So the x value where the gradient is a 0 is the x value of our turning point, because specifically at the turning point, the gradient there is a 0. So what we will, oh snap, I made a mistake. Oopsie. Is it -6? Thank you. This kind of helped because it's on the left side of the x-axis. So remember, the idea is at the turning point, right? The gradient here specifically is a 0. You see. So what we did was in the gradient equation we put a 0 there, and then we solve for x. So that being done, we want to what we want to do. We Highball, come on, brother. Come on, my guy. Come on. What do you want to do? Oh yeah, we want to get the y value of the turning point now. So to get the y value of the turning point, all you do is in the equation of f, right? You're gonna throw -3 there, and then this is like -3 squared, -3 plus a 7. This is 9, so it's like -9 here, plus 18 plus 7. And then watch. Come on, my guy. Come on. Come on, come on, come on, come on. Anyways, what does it say here? -9. Hey, bruh, calculator, my guy. Calculator. Just use the calculator. Don't be a hero. Don't be a hero. So it's a 16. Perfect. So this is properly a coordinate here if you leave it like this. So you can just say here, therefore E is just -3 and 16. And you run. So yeah, well done, man. Got yourself a mark there. The next question says determine the value of k. Why is k? K is the here where the x value is -5. Wow, that's like a very, very easy mark. Because the equation of f of x, we know it's like negative what? Negative that, and then plus 6x. Was that a plus 6x? Oh, minus 6x, my guy. Minus 6x. Minus 6x plus 7. So in this equation, we're going to make x a -5. And then, let's see. Hallelujah. This is like 25, right? 25, -25 here, plus 30, plus 7. Okay, this looks good. So what is going to be the value of k now? Well, the calculator has to give us that answer, because the calculator is super smart and we are super smart as well. Hence, we know to use it, Iron sharpens iron, so they say. So this is a 12. Perfect. Therefore, k is equal to 12. Easy, free mark there. Determine the equation of the straight line passing through C and D. Where is C and D? Oh, so they're saying we should get the equation of a straight line that would pass through C and D. Okay, so the straight line would look something like that, right? Yo, let me see if this thing is gonna allow me to do my special tactic. Nice, very nice. Let's change style here. Let's give you something light. Let us make you blend in, Yana. You know what I'm saying? Let's do this, catching. Do this. Let's see here, catching. Okay, so this is the line we are talking about. They want us to get the what? The coordinates. No, the equation of that line. Oh, okay. Well, anytime you need to get a straight line, right, the best thing you can do for yourself is to start with this format that we all love. This one here. Y is y minus y1, and then m x minus x1. Okay, this is all nice, very nice stuff. This. So with this being said, with this being written down, rather, what do we need now? We need a gradient and we need a coordinate that the line passes through. So in terms of us getting a gradient, fortunately we have the value of d. D is -5 and 12. What is the value of c? What is the coordinate c? Oh, it's 0 and 7, because the x value is a 0, the y value is a 7. Very nice, very, very nice. Anyways, gradient here, it's gonna be 12 minus 7. Okay, -5 minus 0. Okay, very nice. What is 12 minus 7? It's a 5, man. -1. Nice. Which makes sense because this is like going down and stuff. So we have a gradient, so we just need a coordinate that the line passes through. Or we actually don't. We actually don't, because we have the y-intercept already. Remember, c is the y-intercept. So the y-intercept here is a 7. Okay. Well, I guess we can erase that. We don't need you, my guy, unfortunately. But don't worry. When we will need you later, you can come back. But for now, gradient is a -1. What's going on now? Gradient is a -1. Y-intercept is a 7. And then that's it. 4 good marks. Like, watch. Would you look at that? 4 good marks. And this is one of those questions where you're like, where is the 4 marks even going to come from? Because it's like, wow, we just got gradient. Okay. So it's like, okay, maybe 2 marks for the gradient. And then it's like, manje, another mark for the y-intercept and another mark for finishing it. It's like, okay, very nice. 4 more marks here. Dude, why did I do this? I literally did the same thing in the other question there where I wrote down the same question twice. Come on, man. Come on, my guy. Hey. Yeah, it says here 6.4, we need the equation of the tangent parallel to CD that touches F at P. Determine the coordinate of P. Well, the easy thing is that with our parabola, right? Let me actually redraw our parabola here nicely. So with our parabola, this is the big idea, right? This is what our parabola looks like. We have the line here, the straight line that we got. They said our tangent is parallel to our straight line. And then they told us that we should get the equation of the tangent where the point of contact is P. But then to make things easy, if our tangent is going to be parallel to what you may call this line here. So this is the line we're dealing with, right? We're going to have a tangent parallel to this. So let's just copy this line here. Our tangent, remember, a tangent is a line that touches the circle once. So our tangent would need to be somewhere over, come on, man, somewhere over there. This is where our tangent would need to be, you see, because remember, a tangent is a line that touches the graph only once, you see. So since we now know that this is where our tangent would be, what we then need to keep in mind is that the point of contact here between our tangent and our parabola, the gradient there is going to be equal. You see, the gradient of the tangent is the same as the gradient of the parabola at this point of contact. Fortunately, this tangent is parallel to our straight line here. So we already know what the gradient of our tangent is. So whatever our tangent is, right, we already know that the gradient is equal to -1 because it is parallel to this line here that we just worked with. Since our gradient is -1, we need a coordinate that the line passes through for us to use our, our formula to get the equation of our straight line. So with all this being said, the one thing that we need is a coordinate that the tangent passes through. So to get this tangent, this coordinate, we can just use the equation of f of x, in the sense that in the equation of f of x, we need to find out what is this coordinate where the gradient is a -2. So this is our equation of our tangent, our parabola. In our parabola, we need its gradient equation. So this is like -2x and then -6. And then in this gradient equation, we want to work out where is the gradient equal to -1. So the x value where the gradient is equal to -1, let's see here. This can go over to the other side. This is giving us -5/2. But let me not, come on, bro. You skipped literally like, don't skip steps unless it's very necessary. So anyways, here, then you're going to divide by 2 on both sides. And then we have here x is equal to -5/2. That's the way. I like it. That was weird. No, it was not. Bro, come on. We sing that song all the time. Okay, did I just talk to myself? Backward. So the x value is a negative something, which kind of makes sense because it's going to be like somewhere there. It's not going to be at -3, but you can see -5/2 is close to -3. So that's the x value. The y value, we can just get it from the original equation of f, you see. In the original equation of f, we're going to throw -5/2 there. And this is like -5/2 squared. And then -6 and then -5/2 plus 7. And then what? This is like what? -5/2 squared. And it's like -6 -5/2 and plus the 7 there. Wow, oh my goodness, this is like so amazing. Dude, what the hell? Chill, my guy, chill. Relax, my guy, relax. Yeah. So this is the coordinate that the graph passes through. So as long as we have this, we're literally home free, So we can just put all this into our special equation, the equation we love so much. So y minus the y value here, and then the gradient was a -1, x minus the x value there, and then this is like -x, -5/2. This can go over to the other side, and then we can put that in the calculator. Whew, this paper is flowing, but hey, we haven't reached the financial math section. The financial math section, man, I'm just like, I don't know what we are going to see there. But personally, man, I'm not a big fan of financial math, but it's part of the syllabus. So we shall do it, and then we shall just move on from there. You know, because I mean, like in a paper, it's kind of normal for you to have stuff you like and what you may call stuff you don't like. So it is okay. It's all good. It's all good. Moving on. 6.5 says, for which values of x will this be bigger than 0 for 2 marks? Where's f of x? F of x is equal to negative x squared minus 6x plus 7. So here it says negative x squared minus 6x plus 7, right? This is f of x minus 12 greater than 0. Okay, so this is quite interesting, but the easiest thing you can do for yourself here is, remember, with the question, right? The question is asking for where f of x is, no, for where f of x minus 12 is bigger than 0. But the fortunate thing is, if you move the 12 to the other side, you can actually see that, okay, this question is just asking us, where is the graph of f of x above 12? Now, the good news is, luckily, we already know where this graph is equal to 12. Remember, the k, the y value of k was it? The value of k is 12, right? Where's k? There. So all these questions, they're locally connected, one or the other. So since we know that, so let's just put it this way. Let's use this image here, because this image is going to be easier to use for us to justify why this is just a 2-mark question and why we don't have to like do something long and crazy. So with our question here, what we know is this point here, right? The x value was like a -5, the y value is like a 12. This question is asking us, where is f of x above 12? So f of x is above 12. Let me just show you where it's above 12. So let's see here. Let's just get let's get this here. So this here is the point where what you may call. All right, let me just remove this. Come on, man. Come on. Let's see. Let's do this, do this, do this, do this, do this. This is the point where f of x is equal to 12. You see, here and here. So it's above 12 over here. This is where it's above 12. You see. So in terms of giving an answer, you have to know what the other side is. So you're going to say it's above 12 from this x value until this x value. So we need to find out what this x value is, meaning in our equation of our parabola, we have to throw in the x value as -5 to see what two y values we get, because to see which two x values we get, because the one x value is this one, the other x value is going to be this one. But then without even overthinking it, you know, you can just finesse this question, because remember, in the middle here, the x value is like a -3. So remember, these graphs, this graph is symmetrical, meaning that from here to here, it's the same distance from here to there. You see, so from -5 to -3, that's like 2 units. So it will also be 2 units from here to there. There's a 12. Perfect. So this is -1. So it's gonna allow us to easily answer this question down here. You see, this is just a -1 and a 12. So this, you're gonna say here, therefore, this answer, right, your x values need to be, so x is an element of -5 until -1. So between -5 and -1, that's where this graph is above 12. It's the same question here. You can just take the 12 over and, you know, answer this instead of worrying about that, because this will satisfy this equation, or this inequality rather, and this inequality, because it's the same thing. Whew, 7, question 7, financial math. Yo, let's just hurry past this section. You know, I was asking myself, why don't I like financial math? It's because, okay, so to be honest, man, anything that you will like not like a little bit is because sometimes it can be a bit challenging, especially with financial math. the thing is, fortunately, it's not like a lot of marks, but let's see what we can do. How many marks will it take? How many years, bruh, will it take for an investment to double in value if it ends at interest? If it ends interest at a rate of 8.5% per annum. Okay, compounded quarterly. So we're talking about compound interest here. So A is equal to P 1 plus I. Without worrying about anything, let's get our interest. Our interest is 8.5% compounded quarterly. N is what we're looking for. But then they said, how long does it take for the investment to double? So we can make Px and we can make A 2x because the x's are just gonna eventually cancel each other out anyways. So these kinds of questions, I mean, they're everywhere in past papers, in previous papers. So let's throw the information we have in our equation, right? Our value for I here, just on my side, I always like to write the percentage symbol there, you know? It's just, oh, I forgot to put N there. Oopsie. So here, fortunately, you can just divide by X on both sides, get rid of the X's, you see? Divided by X, divided by X. And then what you got? You just got this, canceling that, and then here you have like 2 equal to. This you can actually just leave it the way it is, you know? Just for the vibes. We can deal with it later. So since we're trying to work out an exponent, the one thing you always remember is if you want to work out an exponent, you isolate it. And then as we said, you make this the log. Whatever the base of the exponent was, it's going to be the base of the logs. That's what we call it. And then here, this number goes here. You see, these are in the same line. This is somewhat down there. And then this you can just put in your calculator. In the calculator, we have log 1 plus 8.5 shift square root the whole thing over 4. Then you have a 2 here. That's like 32.96. Wow. 32.96. Therefore, 33 years. See? Okay. This is very nice. This is very good. But let's keep moving forward. Question 4. A company purchased machinery at 500,000 after 5 years. Wait, what? No, there's a full stop there. Yeah. Punctuation marks, guys. A company purchased machinery for 500,000, right? Full stop. Then he says, after 5 years, the machinery was sold for 180,000. Okay. And then he says, and the new machinery was bought. No, and the new machinery was bought. My reading. Wow. I calculate the rate of depreciation of the old machinery over the 5 years using the reducing balance. So this is the reducing balance. Very nice formula, very easy to use. So the original cost was 500. That's a value of P, 500,000. The cost after time had passed is 180,000. And then the interest rate, what is the interest rate? Well, that's what we're looking for. Or rather the depreciation, the rate of depreciation rather. N is 5. You know, it's not compounded monthly or whatever, so N is just a 5. And then here we can just solve for I. So what I prefer to do is we can isolate I here, you know. So to do that, what can we do? We can divide both sides by P, right? A over P is equal to 1 minus that of N. Since, I mean, to get rid of the N here, right, you would put actually make it the next step. The next step, you would put a third there with N here. And then the N's would cancel out. And then here you do the same. So the reason I'm doing this is, I don't know. Not that I don't know, I do know. So this will cancel that. And then you're going to have here 1 minus I. Let's see here. And then it's like N A over P there. So since we're working out I, right, I can come over to this side and then this can go over to that side. This is like A over P. There we go. So let's work out I now. Let's put everything into our calculator. N is 5. A is 500,000. P is 180,000. Nice, man, nice. Let's put everything in the calculator. That's the way. I like it. This is funny. Why are you laughing? 180,000. So this is like, oh no, we're getting a negative value. Ah, man, come on, bro. Come on. Ish. Yeah, this is not fun at all. Because it's like, it's giving us negative value. Come on, man. No. This is wrong. These are supposed to be swapped. Whew. Thank goodness, yo. 500,000. Yeah, so the reason I spotted that was because the answer in the calculator is coming out as a negative. So in my head, I was like, what? A negative? No ways. No ways. 180,000, 500,000. So that's like 0.1848. And then, since we are working with percentages, therefore, it's going to be 1. You're going to have to multiply by 100, you see, which is going to give you the percentage, you know. So we're going to times this by 100. So this is just giving us 18 point. So let's just say, therefore, rate equals 18.48%. Very nice. Okay, so far so good. It says the rate of inflation for the cost of new machinery is this much over the 5 years. What will the new machinery cost at the end of the 5 years? So these questions look pretty decent. Quite simple, actually. Not even decent, just very simple, which is how we like it, you know. This is how we like it. So the new value of we don't know what it is, but then okay, let's just see here. Let's just take things slow. The interest rate is 6.3% per annum. N is 5. And then, I mean, like, the cost of the new machinery. So the original amount is just 500,000. The amount afterwards, we don't know, but that's what we want to work out now, you see. So let's put everything in the calculator. 1 plus, that's why this is just a 2-mark question, you see, because it's just calculator work. So the interesting thing about this question is what? What is the interesting thing about this question? I don't know what is interesting about this question. What do you mean by you don't know what is interesting about this question? Well, it's just straightforward, because I mean, like, here these are two questions that are like almost opposites of each other. One is asking you, because you're still working with the 500 decreasing, and here the 500 increasing, you see, because this is more like to say, you know, the newer models of the machines and all that, you know, they're obviously going to cost you more. But anyways, let's see here. Don't forget the percentage symbol in your calculator if you're gonna do it like this. So the calculator here is giving us 678,635.11. That's the way. I like it. Anyways, these are 5. It says the company set up a sinking fund and made the first payment into its fund on the day the old machinery was bought. Okay. The last payment was made 3 months later, before the new machinery was purchased at the end of the 5 years. Okay, so I need to really read this again but anyways, I think the thing is, right? Okay, so this is what's going on in my head. I'm reading the question, but as I'm reading it, I'm just like, it's just too much information. So the one way to go about questions like this is, as you read it, right, just try and take note of what you can. And maybe if you can do some kind of a timeline stuff thing or whatever, it's fine. So it says a company set up a sinking fund and made the first payment into the fund on the day the old machinery was bought. So on the day the old machinery was bought, they made their first payment into the account. And then they said here the last payment was made 3 months before the new machinery was purchased. wait, the last payment was made 3 months before the new. Okay, so we know that 5 years later, 1, 2, 3, 4, 5. After 5 years is when they want to replace their machines, right? But then instead of like making the last payment after 5 years here, they made the last payment 3 months before what you may call the full 5 years had passed. So the reason this is important is in the whole, if they were to make payments right throughout the entire 5 years, the number of payments they would have made would have been 5 years times 12 plus 1 because of this one here, meaning they would have made 61 payments if they were making payments from here all the way to here. They would have made they would have made 61 payments. But because they stopped, but because they made the last payment 3 months before the 3 months before the 5 years, it just means that this 61 now, we have to remove 3 payments from there, which would give us a total number of 58 payments, you see. So before we even finish reading the question, this is the idea, you see. From this to that, we'd have made 61 payments because it's like 5 years, right? 5 times 12 is 60. Plus this one payment there would have given you 61 payments. But then because they made the last payment 3 months before the 6 years finished, it means it's 58 payments. But then let me read this again. The last payment was made 3 months before. Yeah, it's fine. Let's not psychoanalyze it too much. It says the last payment was, yeah. Then it says here the interest earned on the sinking fund is 10.25% per annum compounded monthly. So that's our interest, right? So I is 10.25 over 12. Forgot the percentage symbol there. And then they said here the money from the sinking fund and the money from the sinking fund and the 180,000 from the sale of the old machinery was used to pay for the new machine. Calculate the monthly payment into the sinking fund. Anyways, so the idea is you have to work out what the sinking fund is, you see, the value that they need to save up. So the sinking fund, as you saw in like the financial math playlist on the Bright Young Brains channel, which is our main channel, the sinking fund is always value of new minus value of old. You see, this is what your sinking fund is going to be. So the value of the new one is this value here, is this figure here, 678,000, blah, 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 blah. So let's put that there. And the value of the old one would be 180,000. So meaning what you need to make sure you have saved up is this figure here that we're about to work out now. That's your sinking fund before you can even worry about answering the question that we have to work out. So let's see here, this number here, 0.11 minus 180,000. So with this being done, let's see here. We have here 498,685, right? 0.11. This is your sinking fund. Sinking fund. So since now we know our sinking fund, we need to now work out what should our monthly payments be for us to eventually end up with this amount here. You see. So I wrote here sinking. I meant to write sinking fund. Come on, maybe we meant to write sinking fund. Sinking fund. There we go. Anyways, let us carry on here. So with all this being said, right? What do we need? With all this being said, we need to use the F formula, because the F formula is the one that allows us to, you know, work out how much money is going to be worth after a certain amount of time has passed if you're making monthly installments. So we need to get a value of X, you see. So we would isolate X here by multiplying both sides by I, which would give us Fi equal to X 1 plus I n minus 1. And then both sides we have to divide by this big bracket, right? So fi divided by 1 plus I of n minus 1. That's what x is. Okay, it looks like we are good to go to get x now. So to get x, let's just, sort out what information we have and what each of those pieces of information is. So f is going to be this value here, our sinking fund, which is 400 and some. This is what we want to accumulate our money to. And then in addition to this, we know that the interest is 10.25% compounded monthly. The number of payments, we said it was 58. And yeah, that's all we need. You see, so F here, I'm gonna put here 498,685.11. What is the interest? The interest is, what's the interest now? What is the interest? 10 point something something. It's 10.25% over 12. Nice. And then what? This is gonna be 1 plus this. And then the whole thing. What is n? N is 58, then minus 1 here. This is definitely the way we like it. Then what? What are you gonna do now? What you're gonna do when they come for you? Oh, you're gonna put everything in the calculator, my guy. So everything in the calculator, you wanna put it all nicely, because you have worked very hard to end up where you are. So hey, do not hesitate, hey. 10.75. Wait, come on, let me check here. 75.12. Then here we have 1 plus 10.7. Is it 7.5 or 2.5? I keep writing 7.5 here, but it's 2.5. Come on, my guy. Come on, man. Hey, I don't even know why my head was thinking of 7.5, but yeah, that's a very dangerous mistake, because hey, those tiny decimals, hey, they cause problems, my guy. They cause problems. This is over 12 to the power of 58, and then minus 1. Whew, okay, equal to I know I made a mistake here because the answer I'm getting, oh, I forgot to put the percentage symbols. Yo. Yeah, ne? Yeah, but I think, look at me wanting to make an excuse. Like, do I have a tiny headache? Just a little bit. No, I don't have a headache, but it is what it is. So here x is going to be equal to, what is x going to be equal to? Our value of x is equal to a very special number. So what is the special number? It is 6,679.30. No, 0.29, bruh. Come on. There we go. Therefore, monthly installment is equal to 6,679.29. Very nice. Oh wow, thank goodness. This financial math section was actually quite doable. Like, wow, man. We love to see it. We love to see it. Why is I laughing now? Look at this. Look at this. 5. Question number 5. We want to work this out using first principles. So using first principles, it's like, this is our formula, right? Fx plus h minus f of x and then h. Nice. Anyways, the first thing you want to deal with is just get an expression for this, because using first principles means you have to use this formula. So get an expression for this fx plus h. What this means is in the equation of h, in the equation of f, right, you have to throw in x plus h in the equation. So here you're gonna have x plus h, and then x plus h again. And then here you're gonna have x times x, which is like x squared, x times that. Yo, let's see here. H times h is like h squared. Perfect. And then you wanna add these two together. It's like 2xh, and it's like h squared, negative h squared plus 2xh plus h squared. Okay, what do we have? Okay, let's move on. So this is what fx plus h is, right? So you can just throw that in the equation here. F of x, you can throw it in the equation here. Take note of this negative symbol, because this is going to say minus this here. So let's see what you're going to have here. I forgot one important piece of information. I'm pretty sure when you're looking, you're like, bro, you forgot the limb. Yeah, this is actually kind of important. Like, yeah, just keep that limb thing there until you're done, actually. So here, limb h goes to 0. And then here we said there's f of x here, right? So just throw in what there's f x plus h here. So we can just throw in what we worked out. And then we're minusing f of x, you see. So remember, f of x is this thing here. And the whole thing over h. Nice. You see? Put stuff in the formula. So the good news is, a minus and a minus there is just going to give you a plus, you see. So we're going to put a plus there. Now this is, the next step is very important. Anytime you have dropped in stuff into the formula, things should always cancel out, like always. For example, here, this is going to cancel this, right? Then you're going to have your 2xh plus h squared over h. And then from there, you can just take out h as a common factor. Lim h goes to 0. So this is like h, 2x plus h over h, right? And then this is that. Lim h goes to 0. This is like 2x plus h. Now you can, the whole limb goes to 0 thing here, right? Oh, I made a mistake. I know I did. I definitely know I did. There's supposed to be a negative somewhere. Here. There's the mistake. Like, wow, bruh, come on, man. It's supposed to be a negative and a negative, bruh. Because when you multiply inside, this is a negative, this is a negative. So, yeah. Change that. So all this is just going to be negative, and then a negative at the bottom here. So negative. So I realized the mistake right at the end here, because right at the end here, now you can throw in the whole 0 where h is, which is going to give you the final answer. So the one thing that was in my head was like, wait, if you use the short way to differentiate, it's just 2 times negative 1, which is going to be a negative 2, and then removing 1 from the exponent. But then here we were going to end up with like a 2x, which was not going to be correct. So that's where the red flags were like, wait, I also need to put a negative here. Negative. So that is all that. Let's keep it moving. Here we just need to differentiate normally, see, because they're asking for, you see how this, the only difference between these two questions is here they wanted us to do it using first principles. The questions down here don't, you see. For 2 marks, they just want us to differentiate. And this question looks like it's actually quite straightforward, you know. Okay, well, it is. That's why it's out of 2 only. Because for a question like this one, you're just going to have here f, and then here 4 times 3, which is like a 12. Remove 1 from the exponent there. 2 times negative 5 is like negative 10, like that. And then that's it. You're done. You move on. Here, for 4 marks, you have to simplify first. So simplifying here, you have to put everything under, you know, this under individual denominators. But then this 3 here, remember there's like technically a tiny 1 there. So what happens is this 3 goes under the 1 there, you see. So you're going to have the x to the power of 1 over 3, and then plus 2. Let me not do too many things at the same time, you see. So the denominator here, which is x to the power of 4, you want to put each term at the top there under this denominator. So meaning you're going to have the, let's see, so this is going to be negative 6x like that over x to the power 4, right? And then 2 here, x to the power 4. Anyways, from here, you're almost home free. Fortunately, what we know is if our bases are the same and we're dividing, we just minus the exponent. So this is a negative 6, right, divided by 1. It's going to be a negative 6. And then here, a third minus 4 is what you're going to have there. A third minus 4, because your bases are the same and you're dividing, right? So a third minus 4 is like negative 11 over 3. Negative 11 over, is it 3? Yeah, it is 3. So here, this has to go up, which is going to give you 2x to the power of negative 4. We say it goes up, but technically what's happening is this 2 is to the power, this 2 has x to the power of 0 here, technically speaking. So technically we say 2 divided by 1 is a 2, and then 0 minus 4 is a minus 4. You see, that's literally what's happening here. That's why but then I mean, like, to make life easy for everyone, you know, we just say whatever we say. And then here we are. Anyways, moving on, now we can differentiate, right? So because now we can differentiate, we can put this equal to sign here. This times this is giving us positive 66 over 3. This I can just put in the calculator, bruh. It's going to give you a 22. Negative 22, actually. No, positive 22. Come on, my bro. Come on, man. Come on. Let's see. Negative 6 times negative 11 over 3. That's like 22. Okay. So it's like 22x minus 1 from here. Let's see what you get. What do you get? Oh, what do you get? I don't even know. What do you get? Let's see here. This minus 1 is like negative 14 over 3. Negative 14 over 3. And then what? Negative 4 times this is going to give you negative 8, negative 5. That's your answer. Very nice. If I made a small error, apologies, man. Apologies. But I think this is all fine. You know, everything is all fine so far, so good. So yeah, let us keep things moving because yeah, we're cruising. We're cruising nicely. Here we are, question number 999. Here we are, question number 999 now. Okay, let's see what it says. Question 9. Sketched below is the graph of f of x, right? Then they said here the x-intercepts of f are 3 and 0. What? And m. Okay, yeah. Then he says where m lies in the negative x-axis. Interesting. Then he says k is the y-intercept of f. Where's k? There is k. And then it says, what is this? N and m are the turning points of f. Okay, that's very nice. So with all this being said, they said we should show that the equation of f can be given by this for 5 marks. So questions like these, right? I mean, like, you don't want to overthink it, really. Or rather, apart from even overthinking it, questions like these, they have like a specific way that you answer them. You don't even need to struggle, you know, because there's literally a specific format. What I mean is, anytime you see that a cubic function has a turning point where it also has an x-intercept, it just means that this equation, right, when it is factorized, firstly, we know that this is what f of x is. F of x is equal to x cubed plus ax squared plus bx plus c. So the fortunate thing is, you already know what this number is in front of x cubed here. This is important. The reason why this number is important is because whenever f of x is factorized, it will always have a value in front here, which will actually always be this. Let me actually make these, you know, the same. So whatever this is, it's going to be this value here. And then you will always have, you know, 3 3 brackets. So the idea is, as long as your cubic function has a turning point where it also has an x-intercept, it means that 2 of the brackets here will look identical. These will look identical. And then the last one will just have, its own unique x-intercept. So the ones that look identical here, they will be representing this x-intercept there. So the fortunate thing is, so when you simplify it here, you're going to have k here, and then 2 brackets that look alike. So you're technically going to have this squared here, and x minus x2, like that. So in our case, our x2 is technically this, you see, positive 3 there. That's what our x2 is. So our x2 is equal to the positive 3 that we have up here, because this is representing the one x-intercept that is unique, which is this one. That's the structure. This is stuff you need to know for these kinds of questions. The reason why this is important is, with all this information, right, we know that k here is a 1. With all this information, we need to get values for this format. If we can get values everywhere here, we will be able to then just multiply out the equation and then end up with something that looks like this. So to do that, fortunately, we have k, fine, we have x2, fine, and we need a coordinate that the graph passes through so that we can at least get x1. So the equation that the coordinate that the graph passes through, that coordinate, fortunately we have it. It is k, you see, x value, y value. So let's put all that information in our equation so we can work out what this is, because that's what's holding back everything. So this, we said it is going to be a -3 because of this, and then k is a 1. This x value, we put it as a 0. This we can just put x1 there. This is also going to be a 0 minus a 3. Okay, looking nice. So it says here, so here we're going to have a -3 times 1, right, which is going to be like -3 here, negative x there squared. So this squared is going to come out as a positive, right? And then you're going to have divide by -3 on both sides. So divide by -3, going to have a 1. This is equal to x squared. This, no, bro, come on. But it is equal to x squared. So the fortunate thing here is you have to square root both sides, you see. The value of this is either plus or minus 1. So you can see it's on the left, so it's clearly a -1, you see. So here you can then say, therefore, that x value is a -1. So the reason why this is important is because now, look at me, I left so much space here, but I'm busy writing everything up here, like what a wow, man. So here we can say, therefore, in our equation of f of x, right, let's what do we need to do here? Let us work with the red one. In our equation of f of x, we can say here, therefore, f of x is equal to, let's put in everything except for the x and the y, you see. So k is a 1. X1, we got it to be a -1. So if you put a -1 there, it's going to be negative times a negative. And then the second bracket, we know it's like x minus a 3 there. And then what? So let's see here. Here you have 2 brackets that look identical. And then a third distinct one. This times this gives you x squared. This times this gives you x. This times this gives you x. This times this gives you 1. And then this is like x squared plus 2x plus 1. And then what? What is next, my guy? What is next? X times that is going to be x cubed. This times this is -3x squared. This and that. Positive 2x squared. This and that, -6x. 1 times that is x. 1 times this is -3. That's the way we like it. So this 1 plus that is like -x squared. This and that is like What is negative 6 plus 1? Negative 5. Oh, very nice. Very, very nice. And then you can see this is exactly what they wanted us to end up with, you see. See? Problemo, negative 1, negative 5, negative 3. And then you move on with your life. You know, you move on. 5 marks here. It says, what does it say? Calculate the coordinates of n. Where is n? N is clearly the turning point. Did they tell us? Yep. N is the turning point. So if we're going to get the turning point of our equation of f of x, is okay. It's okay. Hey, I miswrote this thing here. Minus 5x minus 3. So, oops, that's cute, my guy. So the turning point, you know that the gradient at the turning point is a 0. So what we need is the gradient equation, you see. 3x squared minus 2x minus 5. That's the gradient equation. In this gradient equation, we want to work out where the gradient is a 0. You see. So let's see. We have there, we're going to solve for x here. Solving for x, the best you can do is to just use a quadratic formula. So in the quadratic formula, what we are already expecting is one x value that is equal to negative 1. If we don't get a negative 1 in one of the answers, then we did something wrong. Guaranteed. So let's just put all this in the calculator. Let's see. Before we put in the calculator, I obviously have to like write it out. Let's see. X is a 3. A is a 3 here. C is a negative 5. And then what you get? Our A value here is a 3. Okay, let's see what this looks like in the calculator. Let's see here. Negative 2 plus square root of negative 2 squared minus 4, 3, negative 5, 2, 3. Okay, so x is 5 over 3. Or we should be expecting a negative 1. Fingers crossed, fingers crossed. Let's see what we're getting. Yep, negative 1 as expected. So is good, eh? Is good, eh? Asbong, eh? So obviously the 5 over 3 is this one, you see. So since we need the coordinate, we can just put that 5 over 3 into the equation of the what? Of the cubic function. 5 over 3 cubed. And then 5 over 3 cubed again. And then 5 over 3 again. There you go, there you go, there you go, go. There you is go, there you is go. So all this, we just need to put it into the calculator. 5 over 3 cubed. Yo, come on, my guy. 5 over 3 cubed. Nice. Minus. Minus 5 over 3 squared. And then minus 5 bracket 5 over 3. Yo. There's this pill on my back and it's like, it's not doing the things anymore. Like, seriously. I feel like I should change it. Like, hey, I don't even know how I'm saying it. I'm telling you, but I'm just like, the guy is complaining about his pillow. Like, wow, bruh. Wow. Seriously, bro. Out of all times. Like right now, out of nowhere. Okay, let's see, 5 over 3 here. The x value is, the y value is like negative 256 over 27. Therefore, n is this coordinate here. Does it look right? Yeah, it looks fine. I mean, the y-intercept here is like a negative 3, so this is a bit further down. So it looks all fine. Like, you know, from the way things are, like the value looks accurate, you know, it looks, you know, sensible. But anyways, let us keep on moving. Let us keep on moving. You know, we don't have to waste time with whatever we just got right. Oh no, dude, how many times did I do this thing? where I was doing the same thing twice. Yo, this is how you know when I was making this thing, I was distracted, yo, big time. Oh yeah. It says for each values of x, will f of x be smaller than 0? Well, this one is quite simple. The reason is we have the picture, like the picture is like literally in our face, so we might as well use it to answer this very simple 2-mark question. So you can see why this is a 2-mark question, you see, because we're really not gonna do anything crazy here. We literally just have to make use of the sketch, you see. So let me do this, do this, do this. There we go. Make this smaller. Make this smaller. There we go. Okay, very nice. So they're asking us, where is f of x smaller than 0? So f of x is equal to 0 here and there. It's smaller than 0 everywhere below that. So this is below 0. This is below 0. This is below 0. Whoa, come on, man. Come on. Let's do that. Do that. Okay, so there is an x value here and the x value over there. So this is like a -1. So the graph is below 0. You're going to say where x is smaller than, I was about to say smaller or equal to, I was about to make a mistake there. So x, you're going to say where x is smaller than -1, or where x is an element of -1 until 3. So from -1 until 3, and from -1 until -infinity, you see, those are the x values where this graph is going to be below 0. That's why this is just a 2-mark question, because you can just get it from your image. You see, from here to there, and then from there going to -infinity. 2 marks. What are they asking us for 2 marks here? For 2 marks, they're saying where will f of x be increasing? Okay, so in terms of where the graph is increasing, right, it's also a matter of just looking at the sketch. You see, we might as well copy it and paste it again here, because we can do that, you know. We have the authority. We have the jurisdiction. What does that even mean? I don't know. I really don't. But I feel like it's correct somewhere, somehow. You know, we have the jurisdiction to do it. Hey, wow. Anyways, where is the graph increasing? So in terms of where the graph is increasing, it's all about where the turning points are. Because depending on where your turning points are, what you always have on the left or on the right of those turning points, one side will either be increasing and then the other side decreasing. But you always want to look at your sketch from left going to the right, the way it's behaving. So from the left going to the right, you can see that anytime you're going upwards, this is the part where the graph is increasing, you see. And then anytime you're going to be going down, this is the part where the graph is decreasing, you see. And then again, from the turning point here, it's going to be going up, right? So this is where it's also increasing again. So in terms of where it's increasing, you can see it has everything to do with the x values of our turning points, as we stated, you see. So the x value here, we know it's like 5 over what? Is it 5 over 3? Yep. So the x value of that turning point is 5 over 3, right? So we need it. So in terms of where this graph is increasing, we're going to say where x is smaller than -1, or where x is bigger than 5 over 3. The reason why we're not saying bigger or equal to is because specifically here, it's neither increasing nor decreasing, because it's like stationary. You know, it's like if you're here, you won't be going up or down. But in the moment you keep moving, you start going down. When you're here, you're not going up or down. But in the moment you start moving, you're moving up, you see. So that's why here, it's not increasing and it's not decreasing. It's not increasing and it's not decreasing. That's why here we just say x has to be smaller than -1. And then our x values have to be bigger than 5 over 3. Is good. Concaved up. Where's the graph concaved up? Another question that needs us to use a sketch. So all these questions here, fortunately, if you went through the you know, the playlist on the YouTube channel, like these questions, you were just blazing through them really, because there's a tutorial that's like 2 minutes long on what to do for concavity and for increasing, you know, it's all there, guys. Like, it's all there. Concavity, you have to focus on the point of inflection. The point of inflection is the point directly in the middle of your two x values of your turning point. So this one here is a -1, and then this one here is 5/3, the x value of your two turning points. So in the middle of the x values of your two turning points is your x value of your point of inflection, which is what you need for this question. So let's get that first. So -1 plus this divided by 2. This is going to give us the x value of the point of inflection. I would say that's the quickest and easiest way to get the x value of the point of inflection. The other way is to get the second derivative and you make that equal to 0, and then you solve for x. So obviously, as you hear me say that, it's like, what? So many steps. But it's still going to get you a third here, which is fine. So we know that our x value of our point of inflection is just where x is a third. So we need this because when the question is asking you where is the graph concaved up, all you do is you have to look at the two sides of your sketch. The one side that's frowning here, right? This side is concaved down, and the side on the other side, the side on the other side, well, yeah, this side here is like smiling, you see. So this side is concaved up. So the side that's concaved up, it's where x values are bigger than a third. And then you keep on moving forward. For 6 marks, it says, determine the maximum vertical distance between f and the first derivative in the interval -1 to 0. Wow. What a wow. What a wow, man. What a wow. Well, with this question, you don't want to overthink it, really. I don't know why I gave myself so much space. But anyways, without even worrying too much about this question, the first thing you can do is to just get the first derivative. You see, the first derivative is, well, let's just what the original graph is first, you know, so we can just start from a clean slate, you know, because you don't want to be jajarach. If you're jajarach, yo, you see me now, I'm busy being jajarach. I'm literally saying don't rush, but I'm literally rushing. Like, wow, bro. Like, wow, bro. Like, what a wow. Like, dang it. Anyways, here we are. Minus 5x minus 3. Okay. I'm just literally double checking if that's the correct equation, because it's like, you write it wrong. Hey, it's chai, baba. It's chai. It's tea. so anyways, let's differentiate. Get the equation of f of x, 3x. I say t because you remember chai is t, you know. But anyways, let me stop off ramping. So this is the first derivative. This is the f of x graph. They say determine the maximum vertical distance between these graphs between the interval -1 and 0. So let's see that between -1 and 0 would be in this interval. Let's just see here. Let's just see what we have. So do we need a sketch? Yeah, probably. This equation here would be a smiling parabola. We don't know what it would look like, but I don't think it matters actually. Because if you need to get the maximum vertical distance between f and I think we do need the image. Yeah, we do. The reason why we need the picture is because, remember, let's see what the x-intercepts of this graph would be. The x-intercept of this graph would be, remember, if you solve for x here, you would get an x-intercept of -1 and another one of 5/3. So, and this is a smiling parabola. So your parabola would technically look something like this. Well, the intercept here is a -5, so this is accurate. There we go. And then if you know your theory well, the turning point would be where the x value is a third. You see, There we go. Very nice information here. This is going to be 5/3 -1. So again, in the applications of calculus playlist, you have a tutorial that deals with the what you may call the relationship between the different graphs, as in the first derivative, the second derivative, and the third one. No, the first and the second derivative. Anyway, so with this image, right, it's going to help us to answer this question, because they said we should determine the maximum vertical distance between f and its first derivative in the interval -1 to 0. So with a question like this, between -1 and 0, with your own eyes, you can see that the portion where the vertical distance is the highest one, right, is somewhere here. Let's see here, somewhere here. This is the portion where the vertical distance is slightly the highest. Somewhere here, maybe even somewhere here also. We don't know where it is specifically, but I'm just trying to give you the idea that, the highest vertical distance is like somewhere here. So with that being said, what you may call, this is how you work out a question like this. So here you have to figure out, okay, you don't have to figure out anything, but you can just look at it from what we have done here. This is the point on the equation of f. This is a point on the equation of the first derivative. So this is important because this vertical distance here, you're going to get it by saying the y value there minus the y value there, you see. So let's put here your distance is going to be equal to the y value at the equation of f minus the y value at the first derivative, you see. So the equation of f, what you know is that its equation is just, is it a negative something? No, it's positive, bro. It's x squared, no, cubed, bro, minus this, minus this, minus this. And then you're minusing f of x. So if you minus the first derivative, it's going to be negative this, and then positive that, and then positive that. You see, because you're minusing the first derivative. So this becomes a minus, this becomes a plus, this becomes a plus. Whew. That's your equation of your distance. You can simplify it if you want, you see. X cubed, this minus this is like negative 4x squared. This minus this is going to give you, so negative 5 plus 2, that's like negative 3x. And then negative 3 plus 5, that's like a positive 2. Okay, very nice, very nice. We have our distance equation. So the fortunate thing is, if you want the maximum distance, what you need to do is you need to take this distance equation and you need to differentiate it. So this distance equation, right, we're going to have to differentiate it and make it equal to 0 for us to find an x value that causes maximum distance. So in this distance equation, we need a specific x value that we can throw in here for us to get the maximum distance. But then but for us to get that x value, we have to differentiate our distance equation and then make it equal to 0. You see, this is how all questions that ask for the maximum of something work. You always differentiate it. You always differentiate the equation of whatever you're dealing with, and then you make it equal to 0. So far so good, man. So far so good. Here we have 3x squared minus 8x minus 3. We have to solve for x here, so we can just use the quadratic equation. Let's see here, minus b squared 4ac over 2a. And then we have here x is equal to, battery is dying. Bruh. What is b? B is negative 8. So is good. And then what? B is negative 8, right? So this is like negative 8 squared. Our a value is a 3. C value is a negative 3. And then a value is a 3. Here, we need to put everything in the calculator here. Let us see. -8, -8 plus -8 squared minus 4 times 3 times -3, 2 times 3, that's like a 0, 3. X is equal to 3. Or, what's the other one? X is a third, negative a third. Okay, here we are. So what now? So we're getting X is a negative a third. The reason why this is the answer you want to choose is because this X value is not between -1 and 0. You see, so between -1 and 0, this is where you would have the highest distance between our two graphs. Yeah, let's carry on. So with that being said, we can throw in our distance formula, our X value as a third. So in our distance formula, wherever X is, we're going to throw the 1/3. So let's do it. Let us do it. Oh, looks like this is the first question where I actually used all the space I gave myself. So anyways, let's see here. We're going to throw -1/3 there. We're going to throw -1/3 there. Then we're going to throw -1/3 over there. That's the way we like it. Anyways, let's get our answer. Because we have worked very hard. We have worked very hard for these answers. We must just get them. We must just get the marks. Because but I mean, to be honest, I mean, this was quite an intricate question, one way or the other. So hey, yeah, let us just get the answer and see what we get. So in terms of the answer we get, we can also then just double check with our sketch to see if it is somewhat making sense, which it probably will. Probably will. So let's see here, +2 + 2. What? Why does it look so odd? Yeah, it is +2. So this number is like 2.5 something, but in fraction it's like 68/27, which kind of definitely makes sense. 68/27, so it's like 2.4 something. So 2.4 is the answer. Does that make sense? Yeah, it kind of does, because you see this is like, yeah, I mean, it is what it is. You don't want to over analyze it too much. I mean, 2.5 something is the answer. That's going to be the maximum distance between these two, between the Y value there and the Y value there. Okay, let's move on to question number 10. Question 10. Wow. Yo, look at us. We have made it. We have made it to the finish line. Let me see if this is with the last question. Is there question 11? No, there isn't. What? Yo, okay. This paper even feels like it was short, But let's see. Question 10 says flags from 4 African countries and 3 European countries are displayed in a row. So four African countries and 3 European ones were displayed in a row during the 2021 Olympics. Determine the total number of possible ways in which all 7 flags from these countries can be displayed. So it's 7 flags. 1, 2, 3, 4, 5, 6, 7. When all of them have not been placed in the first position, you have 7 options. The moment you put 1 there, in the second position you have 6. The moment you put 1 there, here you have 5 options, and then 4 options, 3 options left, 2 options left, and then 1 option for the last one. So the number of arrangements would just be 7 times all those values, which is just the same as 7 factorial, of which 7 factorial in the calculator. You don't have to write the 7 factorial part, like you really don't have to. It's just in your calculator, it's going to be easier for you to like write it, That's that. Moving on, 3 marks. The probability that we should work out the probability that the flags from Africa were displayed next to each other. So if all the flags from Africa are to be placed next to each other, if you're going to work out the probability of that happening, you firstly need to work out how many ways can the flags of Africa be placed if they're all supposed to be stuck together. So what I mean is you have 7 flags in total, right? 1, 2, 3, 4, 5, 6, 7. 7 flags in total. We want the probability that the African flags will be together. So before you can worry about the probability of the African flags being together, you need to work out the number of ways that the African flags can be together. So what you do is you literally look at 4 flags and you paste them together and you look at it as like one object. Now what's going to happen here is the way it is now, you want to think of it as like one object and then a second object, a third, and a fourth one. These 4 objects, they can be moved in 4 factorial ways. They can be arranged in 4 factorial ways. However, these flags here that are stuck together, they can also be arranged in 4 factorial ways. So the total number of arrangements here is just going to be 4 factorial times 4 factorial. So the total number of arrangements there, let's see in the calculator, 4 factorial times 4 factorial. What does it give you? What will you get? You are going to get 576. So this is the total number of arrangements if the African flags are stuck together. So the probability of that happening is 576 over the total number of arrangements without any restrictions, of which this here is giving us, let's see, 5040, right? That's like 4 over 35. 4 over 35. Whew, very nice. Very, very nice. We love to see it. This next question, it says A and B are 2 independent events. For independent events, remember the probability of A times the probability of B is equal to the probability of A and B. There we go. Now they say it here, probability of A is this much, probability of A or B is this much, calculate the probability of B. For this question, it looks like you can easily just use the addition rule of probability, because the addition rule of probability says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. You see? So if you put this into the calculator, if you put all the information you have, right? Remember, since the independent events, you can work out this value. Since, oh, no, you cannot. Yes, sir. Wait a minute, you can just replace this with this since you don't have this value. Yeah, wow, man, some creativity, eh? So in our equation here, we can just write this PA plus the probability of B. The probability of A on A and B, we don't have it, right? But we know it's going to be this value multiplied by this value. So we might as well just have this in our formula because we at least have something to put into the formula, since we don't specifically have that value, but we know it. These are the same thing. So when we see this in our formula, we can just replace it with that because they're independent events. Moving on, so from here, the probability of A, they gave it to us as 0.4. The probability of B is what we're working out, right? So actually, let's actually do this. Let's isolate the probability of B here. Let's make it the subject of the formula. So if you take out the probability of B here, there, and there, you're gonna have here wow, really? Yeah, because if you take, oh no, snap, I was about to lie. You cannot take out a common factor here. Yeah, it's not gonna happen. Whew, because this is 1, 2, 3 separate terms. Yeah, I was about to be fancy for nothing. But anyways, let's put in numbers then. The probability of A or B is 0.88. Probability of A is 0.4. Probability of B, we don't know. Probability of A, 0.4. Probability of B, we don't know. So since we're working out the probability of B, this can go over. 0.88 minus 0.4. What do we have? It's 0.48. 0.48. And then this is probability of B minus 0.4 probability of B. Okay, then what? So we need here, technically speaking, this is like 1 minus 0.4. That's going to give you 0.6. And then divide both sides by the 0.6 there. What do we get? So divide here by 0.6, divide by 0.6. We have the probability of B. So what we get? Divide by 0.6 here. That's going to be 0.8. Wow. Oh, such a big number. Yo, yeah, it's kind of crazy, eh, this number. Wow. Yo. Yeah, it is what it is, man. That's what we're getting. So, well, we could just test our answer, see if it balances out. I mean, probably will. I mean, you know, let's see, 0.4 plus 0.8 minus 0.4 times 0.8. Yep, the equation balances out. So this is what we get for the probability of B. A 5-mark question here says there are 120 passengers on board an airplane. And then it says passengers have a choice between a meat sandwich or cheese sandwich. But more passengers will choose a meat sandwich. What the? Okay. There are only 120 sandwiches available to choose from. The probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18 over 85. Calculate the probability that the first passenger will choose a cheese sandwich. What? Oh goodness. So you see with some of these questions, the way they are laid out, it's like okay, so this question, to be honest, because of like all the different kinds of questions I've worked out, the one thing I'm already thinking of here is like a tree diagram of some sort. Because they told us we're dealing with 120 passengers, right? But then they said passengers have a choice between a meat sandwich or a cheese sandwich. So someone can choose meat or they can choose a cheese sandwich. Secondly, they said, but more passengers will choose a meat sandwich. Okay. And then it says here, I mean, that's kind of normal. You know, this is actually realistic. You know, who's going to choose a cheese sandwich over a meat sandwich? People like meat, okay? Unless you're vegetarian, then, hey, I did not mean to offend you, since talking about meat is so offensive. Never mind. Yo, I just escalated so fast. But hey, let's just chill, guys. Hey, let's just chill. But anyways, let's see what am I saying. Then it says about more passengers will choose a meat sandwich. Then it says that there are only 120 sandwiches available to choose from. The probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich. Okay, hold on. We kind of have to be this kind of information, we kind of have to find out a way we can put it in our tree diagram. That's if we're actually going to carry on with a tree diagram. We might pivot and end up not even using a tree diagram. But for questions like these, yeah, it's giving me like tree diagram vibes. So they said here, the probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich. So what that means is the first passenger, they're either going to choose meat or cheese. And then when the second person comes, they're either going to choose meat or cheese. So what that means is, firstly, this is how a tree diagram works. When the first person picks out a sandwich, they're either going to choose meat or cheese. Say they chose cheese. When the second person comes, right, they will either still choose meat or cheese. So say the first person chose meat. When the second person comes, they'll either choose meat or cheese, you see. So this small tree diagram here is giving us all the possible options, right? When two people have picked out a sandwich. So those two people are either going to both pick meat. The one is either going to pick cheese and the first one meat. The one is either going to pick meat, whereas the first one chose cheese. Here, the one is going to choose cheese, and then the first one would have chosen cheese. This is giving us a layout of all the possible outcomes for two people choosing a sandwich. You see, if two people are going to choose a sandwich, this is giving us an idea of all the possible outcomes. You see, they are both either going to choose meat or they are both either going to choose cheese. The first one is either going to choose meat and then the second one cheese, or the first one chooses cheese and then the second one meat. These are the outcomes. So from this data, right, what they have told us though is that the probability that the first passenger chooses meat, so first passenger choosing meat and the second passenger chooses cheese, is 18/85. So this probability here is just 18/85. And then they say here, calculate the probability that the first passenger will choose a cheese. Wow. So the probability that the first passenger chooses a cheese is these two probabilities added up, you see, because calculate the probability that the first passenger will choose a cheese sandwich. So yeah, I feel like, yeah, since this is like the last question in the paper, it's okay that it's, you know, not so straightforward, but it seems to be making some sense, you know, the more we look at it. And with these kinds of questions, the one thing I obviously always do is just read the question as many times as you feel you need to, you know, because it kind of really helps. So since there are 120 passengers on board this aeroplane, right, and there's also 120 sandwiches, the only issue is we don't know the ratio between the meat ones and the cheese ones. That's the problem. Yeah, because I mean, like these 120 sandwiches, some people are gonna have to choose whatever is left once the one variation runs out. So yeah, that's kind of, you know, creepy. But then whichever way, we don't know how many meat sandwiches there are, we don't know how many cheese sandwiches there are. But let's put it this way. Let's say meat is equal to X. It automatically means that cheese is equal to cheese is if the meat sandwiches you have X of them, it means that the cheese sandwiches you have 120 minus X, logically speaking, because there are 120 sandwiches in total. If you remove the meat ones, you're left with the cheese ones. Ouch. So the reason for doing that, the reason for doing this is because, firstly, when the first person picks out a sandwich, right, there's 120 sandwiches to choose from. The number of meat sandwiches, X. Here, when the first person chooses a sandwich, there are 120 sandwiches to choose from. The number of cheese sandwiches we have, it's 120 minus X. Now what happens is when a person, say the first person chose meat, it means that when the second person is going to choose out a sandwich, there's only 119 sandwiches left, you see. So if they chose meat the first time, it means that you only have X minus 1 meat sandwiches left. If they chose meat the first time, it means that all the chicken sandwiches are, all the cheese sandwiches are still there, right? So you still have your 120 minus X cheese sandwiches to choose from, minus 1 meat which was taken out. Let's back it up a bit. So let's back things up, because this is kind of important. You see, let's say that again. If one meat sandwich is gone, it means that the number of meat sandwiches that we have is X minus 1. So the number of cheese sandwiches that we're gonna have, it would be 120 minus the cheese sandwiches. You see, but then does this make sense though? Yeah, it kind of low-key does, you know, kind of low-key does it though? I'm suspecting 19 minus x minus 1. Yeah, I think before moving on here, we really have to psychoanalyze this very nicely, because we might just risk making a dumb mistake here, you know. So if one sandwich is gone, we have 119 sandwich. Okay, that's fine. But then this one sandwich that's gone is a meat sandwich. So in the meat sandwich section, we have x minus 1 meat sandwiches left. But then, even though we have x minus 1 meat sandwiches left, the total number of sandwiches that we currently have is 119. Yeah, because we have 119 sandwiches, and then x minus 1 of them is meat. Yeah, so this has to be 119. Reason being, one sandwich is gone, so we have a total of 119 sandwiches. But then the one that's gone is a meat sandwich. So the initial number of meat sandwiches we had was x. So if you remove 1, the number of meat sandwiches that you have left is x minus 1. Whew! So that's quite interesting. The reason why all this is useful to us is because, okay, technically speaking, all we need is this and this actually. This is kind of useless. All we need is this probability and this probability, because it's going to give us the 18 over 85 there. We need the 80. We need to write out that calculation for us to work out x. If we can solve for x, I think this question is going to be much, much easier, like literally. So let's just solve for x quickly. So solving for x, we can put there x over 120 multiplied by 110 or 119 minus x minus 1, the whole thing over this. This is equal to 18 over 85. Very nice. Okay, what now? Now we just do algebra. Did I give myself space? Away. Anyway, so working this out, you have to be careful, you see. So let's put the x out here. Let's actually do it on the next line nicely, you know, because we have plenty of space. So x is here over 120 nicely, just chilling. This is multiplied by 119. So if you multiply the negative inside, right, it's going to be negative x plus 1 over 119. And this is equal to 18 over 85. 18 over 85. Okay, moving on. So these are being multiplied together, right? So 119 plus 1 there is going to be 120. Uh-oh. This is scary. Oopsie. Whoopsie. Oh well, makes sense to a certain extent, because I mean all the cheese sandwiches are still there, right? So x 20 minus x over 109. Logically speaking, that makes sense. And then here 120. And then this, you can see how I'm taking it nice and slow, because there's no need to rush. So here, this, remember this is in brackets, right? So this times this, and then this times this. So this times this is going to give you 120x negative x squared. The denominator here is 120 times 119. 120 times 119. Let's see what we get here. 120 times 119. That's like 14,280. 14,280. We have 18 here over 85. What do we get? What do we get? What do we get? So we can cross multiply here. This times the 18. Yo, we're working with big numbers here. Yo. Yeah, them big numbers be discouraging sometimes, but hey, we gotta keep going because we have gotten way too far. Ooh, 200 and something. Yo, 257,040. This times this would give you 85, right? With 120x here, and then here negative x squared. Perfect, perfect, perfect. So let's multiply inside here. 85 times 120, that's like 10,200 x, and then 85 times this, that's like negative 85x squared. This is 250 da 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 da. This is what we have here. Okay, fine. Everything seems to be going very nicely, right? So let's take everything to one side so that we can eventually then use the quadratic formula. Remember, the quadratic formula does not discriminate, you see. So even if your numbers are big and stuff, it's fine, you know. So 85x squared minus 1200x plus 250 da 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 da. Yo, don't make a mistake now, my guy. Come on. We have worked very hard for this. You know, we have worked very hard. Let me see. So in the quadratic formula, right? So x is equal to minus b plus minus b squared minus 4ac over 2a. This question, I feel like they should have given us like a good 7 marks though. Like these people, they just mean. Let's see, x is equal to minus b and then plus minus b squared minus 4a is 85. C, such a big number though. But this one is also a big number. Yo, I don't know if the calculator can actually handle these numbers. I don't know. My suspicion is it's gonna give us some math error. I don't know, or something, because these numbers are maybe too big. But if it does that, we'll just see what we can do. You know, we'll just finesse the question. Maybe check out a common factor of some sort. So let's see here. Fraction button minus 10 and 200 plus square root negative 10 and 200 squared minus 485 257 040. The bottom there we have 2 and 85. Yo, 84. Ooh, x is 84. Okay, that is very promising, That looks so good. But that looks so scary because it's like, yo, so many meat sandwiches. What a wow. Oh, it kind of makes sense that we have so many meat sandwiches because what? Oh wait, no, x is, wow, 30, 84 or 36. Oh, hey, this is interesting. Because now we kind of have to pick wisely now, like legit. I feel like this is one of those things where it's like, both of them work, or rather, both answers look kind of valid. So I think this is where things get interesting, you know, because if x is 84, wait, why can't these numbers add up to? What do these add up to? Doesn't this add up to 120? Coincidentally, it does. Wow. Yo, I think it makes sense because either one of these could be the meat or the what you call, or the chicken. Or the cheese. Keep saying chicken. Anyway, so we have a value of x, right? But then let's see here. They said the probability that the first person chooses meat and the second person chooses cheese is 18 over 85. Calculate the probability the first person will choose a cheese sandwich. Whew. Well, since we have our value of x, it makes this question a bit easier now because is if we know the fortunate thing is it doesn't matter which one is 84 and which one is 86. It really actually doesn't matter, because these, yeah, it really doesn't matter. Like mathematically speaking, it doesn't matter. The only thing now is for us to work out the probability that the first passenger will choose a cheese sandwich. We have to know what this probability is, and we need to know what this probability is, because these two probabilities incorporate, these two probabilities are the two probabilities where the first person chooses what you call cheese. So we have to know what this is. We actually really do have to know what that is. But the easiest way to work this out, it looks as though the easiest way to work this out, well, since we now know what the x value is, I mean, it kind of makes our life much, much easier, because since we know what x is, right, we can just take this portion of our question. Let's take this portion of the question here, and then just put in actual numbers. You see, so let's just copy that, drag it down here. Oh, look at that, we have a portion down here. So paste. So this portion down here, we can just put in numbers. You see, we can just put in the numbers that we can that we actually have now. So it doesn't matter what you make. We worked. It doesn't matter which x value you choose here. They are both valid. They both work. So I'm gonna choose x as what you may call. But no. Wait. Let's see here. They said passengers have a choice between meat and cheese, right? But more passengers will choose meat. So since more passengers will choose meat, it means that x has to be the bigger number amongst these two. You see? So here we have to say, we have to choose 84. So if x is 84, it means that here we're going to have here 120 minus 84, right? Which is going to be 36. And then here 36. And here 84. Because firstly, this is the probability of choosing a cheese sandwich here is 36 out of 120. When one sandwich is gone, there's 119 sandwiches left. So the probability of choosing, oh no, this is actually one less now, because one is gone. So this is 135. Here all the meat sandwiches are still there, but there's one less in total. So the probability of choosing cheese and then meat is gonna be, remember how this works is it's just gonna be this here multiplied by that value. So what is that gonna look like? 36 over 120, the whole thing multiplied by 84 over 110. That's like 18 over 85. So this multiplied by this is giving us 18 over 85, which is very crazy. And then here, this multiplied by this, what does it give us? It's giving us, because cheese and cheese again, the probability of that is going to be this times this, right? Which is, let's see here, 85 at the top. And then what are we going to get? This is like 3 over 34. 3 over 34. So the probability that the first passenger will choose cheese is just these two added together, right? So 18 over 85 plus 3 over 34, bro. Come on now. 3 over 34, right? Is that what the calculator says? 3 over 34. Yep. Anyways, with this being done, let's put this in the calculator. 18 over 85 plus 3 over 34. That's like 3 over 10. Whew. Wow. I don't even know how long we spent on this question, but you yeah, it was an interesting question. And yeah, I mean, like, remember, I'm making this memo. This is like a few days after it was actually officially written. But anyway, so if you spot any small errors, probably like maybe, yeah, like, I actually think this is one of those papers where a lot actually went right. But I mean, like, I am not a robot. I am not a robot. Reminds me of this K-pop series that I watched. What? I think I watched only season 1. Did I? Does it have many seasons? No, I don't know. Whichever way, I think I watched like only a few episodes. Yeah, I'm not a robot, people. So, but anyways, I think, yeah, we made some really, really good I'm trying to say this was a good paper. I'm like, honestly speaking, this was a good paper. It was, it was, it was up to standard. It was good. It was okay. So it's all good. I'm literally gonna set up paper number 2 now, and then have a go at it at some point in time soon. But for now, remember the one thing you can do for yourself is this. You see what we have worked on in this paper. For you to be able to work on those kinds of questions seamlessly, right? You definitely want to sign up for the online courses on the website. See, the link to that is in the description. Just sign up for the All Access Pass. The All Access Pass basically gives you access to the entire syllabus. You see, that's what the All Access Pass is. All Access Pass. You see, I highly recommend it. You will not regret it. From my side, obviously, if you need to hit me up, let me know of something, or if you have a question, etc., you can always just hit me up on IG at LE_EVY. These are good. I will catch you in the next paper. Don't forget to, plug your friends. Let them know that this channel has full past papers from start to finish. And then the main channel is actually Bright Young Brains, where we post like, tutorials of the syllabus and all that. But then, yeah, if this was helpful, don't forget to like the video. But anyways, it's all good. I will catch you in the next tutorial, which I will record soon.